फेसबुक, इंस्टाग्राम, व्हाट्सएप और ऑक्यूलस कई घंटों तक डाउन रहे। इससे यूजर प्लेटफॉर्म फिर सिस्टम.com को प्रोटोकॉल है। फेसबुक से इंटरनेट में कुछ किया जिससे फेसबुक का नेटवर्क बाकी इंटरनेट से कनेक्ट नहीं।
जो
सर्विस चाहिए और
पेशे से फैशन मॉडल है और दिल एडिक्टेड बताया जा रहा है। वो अक्सर कहीं भी घूमने निकल जाता
है। अंजना ओम कश्यप वीडियो में गुनहगार कब होंगे गिरफ्तार? लखीमपुर खीरी कांड पर एक के बाद एक कई वीडियो सामने आए हैं। किसी में एक गाड़ी नौबाशी
के फोटो
सारी चीजों को और पत्थर चला पास हुए बहुत अच्छी चीज है। किसानों
वो हमला सीधे गाड़ी पे करना चाहते थे।
जाता है।
Real reports come out.
एसएम प्रधान का बयान भी सामने आया। क्या कहा उन्होंने, जरा सुनिए।
इस पर कार्रवाई पहले से ही हो रही थी। लगातार हम लोग इंटेलिजेंस गैदर कर रहे थे और ये भी था कि इनपुट्स पक्के हो जाए। पक्के हो जाए।
देश का मिजाज में जो पहला सवाल हमने लोगों से पूछा और परसेंटेज के साथ हम आज शुरुआत करने वाले हैं कि अगर आप
इस पर कार्रवाई
Hello, this is a presentation from the forensic engineering. At normal, okay. All right.
Assalamualaikum and a very good morning to the ladies and gentlemen. This is to inform you that the second day of the seminar will be starting in 5 minutes. Kindly be seated. Thank you. Assalamualaikum and good morning to the ladies and gentlemen. Ladies and gentlemen, on the first day of the seminar, we have listened to 5 presenters on forensic research, cutting across many areas such as road, structure, and buildings. Today, we continue our second day of the seminar with 6 more speakers on board.
Today, our fellow speakers will be Dr. Payam Shafiq from University of Malaya, Engineer Eliani Yazrin binti Abdurrani from the Road Branch, Public Works Department of Malaysia, Professor Engineer Dr. Raizal Saifulnas bin Muhammad from University Putra Malaysia, Mr. Nur Azlan bin Abdullah from the Centre of Excellence for Engineering and Technology, Public Works Department of Malaysia, Dr. William Chiang Wylem, Sequent from Bentley System Singapore, and last but not least, Dr. Muhammad Nizar bin Abdul Rahman from the Slope Engineering Branch, Public Works Department of Malaysia.
I would like to remind the audience during the presentation, the audience may post the question on Facebook Live comment page or YouTube. The question will be forwarded to the speaker during Q&A session.
Ladies and gentlemen, without further ado, let us hear the first speech from our first speaker for today. The presentation will be given by Dr. Payam Shafiq from University of Malaya with the title of Defect Prevention Measures in Concrete Building Structures at Design, Construction and Service Stage. Dr. Payam Shafiq, the floor is yours.
Hello, good morning. Thank you, JKR, just invited me to be here today and then share some of my experience, knowledge by the other colleagues in the construction industry and extend some of my concern for better service life for our buildings and end user. And I believe that this seminar also, the main aim of this seminar is for that. Okay, I am happy to be here. The main issue in the defect in the building now, everybody, especially end user, are concerned on that, talking about the repair other than after construction. But I want to highlight this issue that this defect that in end user nowadays they are suffering, we can somehow can say without extra cost, we can prevent during the design, which is need to special attention from our engineers during the design stage, during the construction, and even during the operation stages. Maybe very simple, what I am going to present here is not complicated. Everybody maybe we know, even no need to be very, very expert, but just special attention on that, we can prevent this defect, and then the people can enjoy from the end, or in the end user can enjoy from using any structures. Talking about the defect, we measure just a simple extension and definition of the defect is the member is not functioning. There is not good performance, or end is not based on the expectation of the required expectation from the users. And it backs to the skill and care. Skill and care from both parties, from the professional and end user. So skill mainly back to our professional and care. But we have the end user have to be care on that in the management stage. But depends on the type of the failure. Failure can be minor or major. Now we focus mainly on the major. We'll have significant effect to the end user, even from their emotional or about the cost. So we are going to focus on here. So you see how you can imagine that maybe your room is in this is a bungalow by the price of $1 million. But you see the user is using like this, hesitating to use in this building by this crack. and in Bangalore, because of the area there constructed this building had the settlement. So what we can do? What we can do is the next stage, maybe is not this talk, but I want to extend this feeling that really how the end user suffering. Doesn't matter, it is a high end or it is a low cost, doesn't matter. Defect is defect. For example, is another building you can see here. This is a defect in front of the two units, is a building something about 25 years. So need to be rectified. It was rectified in another slide I show, but I want to mention there is not something collapsed here, didn't reach on that point, but the end user, when they face this defect, is not feeling good. In a study conducted in one university, if I'm not mistaken, UITM, they come up to have a survey between the end in the building owner. They said, what is related to the defect? What's effect you to your feeling, and then what is your sensitivity? There are two things that people thought that they get sick if the first thing was aircon was not working well, meaning that they are not happy or they are not comfortable as inside the room they are using because of the good functioning of the aircon or fan. Second thing was they may get sick from the building they are living is defect. They see the crack, dampness, leakage. So who should provide this part? I think we as a expert and authorities. I back to these other photos is later on. Just before I go to the concentrate to the defect, let me just a little bit I explain about the concrete, because we are going to have a concrete. As you can see everywhere we have in Malaysia, because of the climate, I think more than 90%, at least in the residential building, there are the concrete. You see the concrete column, beam. So a little bit I explain about the concrete. So concrete is the most used material after the water in the world. So this concrete has huge advantage. And maybe, yeah, of course, there is not excellent material, construction material, but we have to know advantage and disadvantages. I just highlighted the advantages of the concrete, that why in tropical region or even dry regions, they are using the concrete. It is because of the low cost compared to steel. So nowadays, after COVID-19, I mean, steel everywhere going to increase because it is a manufacturer. But the concrete is something, stone, aggregate, cement is available everywhere. So it is a low cost. So everybody can make it. But of course, if go to the higher standard, not everybody can make it. So it is available, low cost. Strain is very good. When talking about the strain, meaning that if we have a piece of the concrete, if you press it, so it can resist a lot, means that strain is very high. The raw material available everywhere, no need to be very skilled people. For example, if you ask me, Payam, to come to make a steel structure, immediately I worry about steel welding, assembling, the pieces. So, but the concrete is not like that. We can find easily, we can make a concrete formwork. Maintenance is easy. Even it is a concrete in the structure, even for the pavement. Maintenance is easy and low cost. It is a very good in the fire resistant compared to steel, something about 2 hours, more than 2 hours in the high temperature can resist, but still maybe something about 30 minutes, maybe more or less, but significantly is less than the concrete. That's why a steel structure needs to be protected from the fire. Many of the waste and disposal from other industry we can use inside the concrete as a mixture to make it durable and sustainable material. And risk on the fatigue and okay, no need to go maybe on very detailed. We have more tasks, but overall it can be a durable. The last one is talking about the durable. Maybe this is the point of we are lacking on that. So later maybe I can prove it, and then how we can prevent and achieve the durable. Means that a building, a structure, a concrete itself is a durable, but during the construction, we have some failure that it is not maybe durable. That's why a building concrete that based on my surveying and asking the other professional, I asked, what do you expect that a concrete building can function? Usually the answer was 50, 60 years. But to me, as working long time in the concrete technology, it must be much more. For example, our expectation must be more than at least 100 years. Why 100 years? A building is like a human. A human just if take care the body, food, exercise, if we take care of ourselves, our health, we can last to 100 years. Many people nowadays, more than 100 years can last. But building also easily can be more than 100 years. We don't hesitating about that there is some major defect and then there will be collapse. So how we can achieve it? To me, it's not really difficult. There is some disadvantage. Concrete, as I said, is very good in the press, but if you pull out from the both sides, under the tension, it fail very fast. So how much it is strong in the press, but in the tension is very poor. Is the sizes of the structure element is higher than a steel structure, occupied more spaces, which the architect don't like it, and it is quite heavy. Therefore, need heavier and more and stronger foundation system. So, just back show that this photo is luckily in Malaysia we have now high skyscraper in the world. So in this skyscraper that two recent built and under building as in the Malaysia is we are proud of this type of the buildings by high technology of the concrete construction is under constructing they are using. But I highlighted here just to show that the main material here is to be used is concrete. For example, in Merdeka 118, in the first, I'm not very sure, but 20, 30 floors, they are using very high strength concrete in the cube strength about 100 MPa. So means that, or KLCC is constructed a long time before, is something about 80 or 85, I heard. So meaning that very high quality concrete we can make it is available in industry. And also this material is already applied in the superstructures. But what the quality that we are using the high in this type of the important structure, I think there is not some attention for the normal buildings. So let me just a little bit explain about the concrete ingredient. I just make 3 types. I call it traditional concrete, normal concrete, and advanced concrete. Just please see the differences. This color shows that the volume of the aggregate is coarse aggregate, fine aggregate, we call it just stone and sand. And the rest are the cement and water. If the mixture is, admixture is something about in 1, 2, 3 ingredients, we call it traditional concrete. It means that no more we can use it in the industry. Unless there is some others, there are additives. For example, as a normal concrete, we have to use additives. Here is we call it super plasticizer, I show later here. And as an advanced concrete that was used, I know the ingredient of the concrete is Merdeka 118 already used in the recent maybe developed and then concrete technology based on the latest technology in the concrete they use in Merdeka, which is overall like this type of the mixture. So they are use the super plasticizer mineral admixture. From here, you can see the differences between the traditional to advanced concrete. Just the differences is this portion. You see, it is too small of the volume of the concrete or this material, which if we use it in, I believe, in all our buildings and in the construction, then our buildings can function maybe more than 100 years and easily with less defects. Just I bring here is this so-called advanced concrete. To me, it should be normal, but okay. So what we are using here as a mineral admixture, you can see some type of the powder. It is other than the cement. One or two type of this powder form we are using. Together by chemical admixture is another type of the additives, just one or two type of this chemical which is liquid form. So if we use this portion together by cement, together by the aggregate, and we apply the concrete and practice this type of the admixture, so very sure is our structure will be more durable and we prevent a lot of the defect. But who should specify? Who should specify we have to use this ingredient during the construction for our building? It is definitely in the design stage. That's why in the design stage, when we are going to design a concrete structure, like for example, normal or a skyscraper, so designer can decide. So even for normal building, recently we have experience for a very normal building, we are using this advanced concrete because of durability. Meaning that recently I realized that engineers are aware about applying advanced concrete to just for our normal buildings. So again, I'm going to a bit more technical, talking about the properties of the concrete, which is properties that are important for quality and effect the durability of the building. Okay, when we make a concrete from either in the side, we mix it, aggregate cement, water together, it is fresh, it is like liquid and viscose. So, or by the concrete trucks arrive to the site, and then we have to test on when it is still fresh before placement. One of the important tests is we have to assess workability. The others, I'm not going on that. Okay, workability is related to the water. As you can see here in the mixture, water need to be inside the concrete mixture for cement hydration. So definitely we need. Okay, when we add the water inside the concrete, you can see on the bottom here. So if we add more water, concrete will be more workable. I mean, all civil engineers, they know, and easily can place and do vibration and then do finishes. So work will be easy. Even the truck can discharge the concrete easier, can be pumped easier. You see, all talking about the easier. But this is one of the issues that on the site we have to be very careful during the construction. So who is going to, on the site, to manage and take care about the adding the water inside the concrete and control the workability? So this is important. When the concrete got hardened, so we have to other evaluation and test in the hardened state. It get hardened. Few hours later, casting, concrete start to be hardened. Day after, definitely it is hard if you touch it. So the hardened concrete need to be tested, evaluated. There are different properties that we need to test. But again, among all these things, the compressive strength and tensile strength tests are important, especially compressive strength. So concrete in tensile strength is very low. As I said before, the compress in the press is very good, in the tension is not good. That's why when talking about the concrete and concrete structure, concrete without a steel rebar is nothing. So we are using, as you know, maybe you were in the construction site or not, you can see that, you know that, you're aware that there will be some steel rebar being used inside the concrete structure. But because the concrete in the tension is approximately 10% of the compression, due to the weakness of the concrete in the tension, tensile strength, so it must be reinforced to function as a composite material to be used as in our structure. So due to the material to be used for reinforcement is, we call it a steel rebar or the fibers. So if we don't use it, or we use less, or there is a failure on the design, so there will be some crack and damages in the structure. This is a normal structure, I mean new structure, but here is showing that I'm showing tested beam, reinforced concrete beam is already failed, but you can see the failure can be appear like these damages, we call it, these damages in the red color, I show in the real structure. We have see, if there is some damages, will be in this area in the red color. So there are some crack, vertical and horizontal, vertical crack and diagonal crack. So I just highlighted, if we have a failure on the reinforced concrete structure, the failure, either it is a type of the crack or damages, like here, will be in the real structure, will be in these zones. So no need to go maybe too deep on that. But during the forensic engineering, the all forensic engineer or engineer, they aware that that's why they need to visit, they need to assess, for example, where is the damages, type of the damages, they need some measurements and then come up by conclusion about an analysis and conclusion that building is safe or not, or how we can repair it, do repair. But let me extend further, talking about when I mentioned here, we need a rebar, a steel rebar or fiber to be used in the concrete. So I wonder, nowadays we are not using this type of the reinforcement, we call it fiber reinforced concrete. We are not, why we are not using, really, it is my question to the even engineer, it is in design stage. It is very obvious that we have a lot of the advantages if we use the fibers. Even I had a surveying study myself when I was working by the batching plants. I asked them how much they have a order to use this fiber, either it is a polypropylene fiber in non-metallic and metallic fibers inside the concrete. Here is a portion of the concrete that already steel was used inside to strengthen the concrete. And you can see there's another study, 1, 2, 3, 4 type of the concrete, and the bottom I mentioned, it was highlighted. This concrete, you see the crack on the surface is 0 fiber, no any fiber, right? And then a slightly increasing 0.1% fiber, and then a slightly, when we increase the fiber inside the concrete mixture, so no crack already disappeared. I think this is fantastic. I think it is already proved in front of the scientists. A lot of the proof we have that if we use any type of the fibers inside the concrete mixture, we can prevent a lot of the damages and the crack and failure. Where, for example, in the swimming pool, I believe if I am a consultant or anybody asks me, where is the urgent and definitely we have to use, I want to insist that we can use in the concrete slab, we have a swimming pool. A lot of the damages, unfortunately, sadly, I can go to the residential building, either the building is a new or old. The oldest building that's suffering is something about 30 years. To me, 30 years is like a 30-year boy, girl. So it's still young, but the end user is suffering a lot. They have to pay a lot to just repair it. So to me, if during the design, our engineer take care about and insisted to use this technology, which is not old, but we don't have attention on the during design stage. I'm sorry that I'm saying like that into the engineer, to be honest, because a lot of the time I was so sad when I see, oh my God, these damages, leakages, defect in this swimming pool. So how the people have to spend the money to repair, to me is very difficult. But during the construction, either the developer like it or don't like it, owner like it or don't like it, engineer must insist because of the risk, another 30 or 40 years, or 50 years, 60 years, we have to use these additives. If you ask me how much is it, to me it's very cheap. Let's suppose a 1 meter cube concrete, just I'm giving the just rough idea, is 1 meter cube concrete grade 30, something about 280 ringgit, so it will be 350 ringgit. Maybe more or less, depends on which type of the fiber you are using. So to me, it's nothing. Building defect is when we have a defect on the structure member, this is really a big concern for the end user. That's why you see how even I given this picture, that easily we can feel how the end user and the owner of the building, they suffer because of, even it is not a structure, there is not talking about the collapse, but even in the viewing emotionally, what the people are feeling really will get sick. So how can rectify it? How much I have to pay to rectify it? So professionals means to their duty of care even much more. The duty of the care, I'm giving the one example here. It was, you can see a level of the duty and responsibility that we, engineer, developer, we have to care on that and think about the end user. It is just one example. A contractor had the concrete pavement in front of a garage, and then after the construction, 6 months after, they observed some crack, there was some holes on the pavement concrete, and the owner was not happy to see these defects. So then the contractor came, demolished again, and then first studied why it was happened. They discovered that the concrete grade, strength of concrete was not was low. That's why there was some crack on the surface. And then they demolish and reconstruct. Wow. So reconstruct everything again. So it is a responsibility. It is a responsibility that we need to know. Even during for the new concrete, they use a type of the fibers to prevent the crack, because using this fiber can prevent the cracks. So the new building, they use it. So, but this is not something dangerous, right? It is not big hole that the people trap on it and then injure, just because of the feeling of the owner, feeling of the people. So, but what happens if our structure has some damages? So we reconstruct? Of course not. I believe we have to prevent during the design. When we are designing a building, so we have to think about people have to live inside the building safely more than 100 years. So, and if there is some damages, there should be some improper way to repair. Talking about the repair of the of the concrete structures, the standard was not developed like design. 10 decades before, there are a lot of the standard, international standard, national standard. Every countries are developed and improving, even the Malaysia. So developing the standard for design and construction. But for the repair, just there are not all standards, unless these two that highly recommended. American Concrete Institute recommended a standard, and something about 10 years, so means that's why it is still young. And also European standard, which is included the 10 chapters. Just I show here, those are interested to the repair. There are 2 good references for repair of the defect. We are not going on that. Just our focus is today is defect come from where, and then how we can control it. Okay, I reached to maybe the main points here. that defect come from where? Value engineering. In the engineering is very common and well-known words. And I know in Malaysia also applying. So from now, just at the beginning, I say I am against the value engineering terms, because the definition of the value engineering is to bring the value. And in the wording, meaning that value engineering or value analysis, we call it, or come from value planning, or so-called cost, honestly, cost cutting. Is it cost cutting from the meaning of the value engineering? But the purpose of the value engineering is to bring the value by reduce the cost, and while the performance still maintain the same or improve. And even when talking about the improve the performance, usually there is not significant if it is. All right, so if you see that just this simple function here, value is come from function to over the cost. We suppose that the function to be same or a little bit maybe improve, but to bring the value, so we have to reduce the cost. So reduce the cost come from where? Maybe come from the material and maybe the time or tools we are using. So bring the value. But what is the problem come from the value? Just as an example, not only on the structure, even for example, just mechanical, let's suppose just as an example, mechanical isolation. So in mechanical isolation, the material will be eliminated to be designed, and then to reduce the cost. Okay, we reduce during the construction, but during the operation, we need the owner needs to pay more because for the energy. And in the structure design, following the minimum standard requirement. This is another issue that as I'm being the structure engineer, this is we have to maybe blame from some of the designer stage. I heard from some of the colleagues just recently that the investor, engineer, to bring the value for to be somehow, we call it efficient design on the cost, and then maybe developer be happy on that. They use the less elements of the structure member. For example, I show you later in some other my slide that instead of using for example, 4 or 5 secondary beam, they reduce this 50%. But the result is based on the standard. But because we are not ready, our construction industry, our contractor, we are not ready for work on the border lines, and then we are not very accurate. We are not, our machinery, our workers are not so skilled. So we should use the more safe, and using the more safe structure by adding our structure element. So let's suppose in 50, 60 floor building, each span, we use one less beams. So you count how many floor we have, and then how many saving that we can have. Definitely, one investor, they like it. I never blamed so far any developer. I never blamed the investor, because simply they want to make money. But I have to blame our engineer, that who wants to make must insist to the quality. Yes, they design based on the quality, but they also know that what they design and deliver and send for the construction what you giving the detail can exactly be constructed under this detail. We are so-called, we have a good skilled worker, very good contractor. Which standard in the construction industry we have? See the reality in the market. So if you are not ready on that, so why you are designing on that? You know that there will be some failure during the construction. So why we insisted to just do our job and then leave it to others. I really, when I see during the design stage, there should be a lot of the care and responsibility. Maybe we will not get the job, we will not award the job because my design is 10%, 2%, 3% is more expensive than the design of the others. I think should not be on that way. I'm just giving the value engineering is not something that I don't like. It's even for developed countries. She is was involved in Charter Association of Building Engineer. Engineer Hackett, if I'm not mistaken, the wording. Okay, she believes that even from the UK, Charter Association of Building Engineer was involved there. She believes, it is her term, value engineering should be deriven from the construction, and value engineering is anything but value. It is cutting costs and the quality. So, means that even in the developed country, their standard is maybe different and better. So maybe engineers don't like the using the value engineering to be applied. Okay, here, maybe after this, I'm showing some more maybe photos and then showing the defects and come up by how we can prevent it in which stage. I ask here, whose fault is it? To me, a very nice and wonderful landscape you see, swimming pool, good, beautiful landscape. I just walked around, really, I enjoy. But what you enjoy from here, and then you suffer from the bottom. Bottom underneath is parking area. What's happening is really simple. You see, because of the rain coming from here, there are some failure on the waterproofing. So this is the beam under this, exactly under the swimming pool, already wet, and this is a concrete slab under this landscape area. What's happening? Easily the water is dripping, so we have a leakage. So what is the solution? Just temporary solution. The contractor came and then inject and fill up the cracks from the bottom. But is it working? Definitely not. It is really temporary. So inject the concrete. You see the dark color here, just recently injected. And so water can find the way another way. Just so it is a continuing. And can say almost all this area are already wet. My question is here, when the building is something about 20 or 22 years, very young building, asking what we do here. Of course, those knows the principle and very basic. So we have to do something about the water from the top. So what from the top we have to. So how can do it here really? We remove all the landscape, do waterproofing again, and then, wow, how much cost is it? So cannot imagine really. So I asked many experts on the waterproofing. So I found that the best waterproofing system for membrane or bituminous or any type, they can last maybe 15 years. So the manufacturer, even contractor, even they give the warranty for the material for 10 to 15 years, and also the workmanship, something about, even there are some workmanship sometimes 2-3 years, but there are some workmanship warranty 15 years, but all talking about the 15 years, 10 years, 15 years, but we are going to leave this building for 50 years, 60 years without headache, huh? But really this is the headache. To me, definitely it can be, we should prevent this big failure during the design. Engineer must take care of that. What's happened if there is some leakage inside? Okay, when we have some dampness leakage from the top, either it is from swimming pool, which is always adding the coloring almost every day, or few days, or weekly, and then this is a coloring, even for in the landscape area, is exposed to the rain. In rain, the our rain, the rain in the KL is more acidic in the city areas. So it's acidic, already acid, means that it's damaged the concrete. Concrete itself is alkali. It still should not reach to the acid environment. It's still rebar is embedded inside the alkaline material, which is concrete. If I think it is easier, we know from the physics that if a piece of the steel be inside the acid, is melt, gone already. So we have to protect it. But this low pH water will penetrate, as you can see here, penetrate inside the structure, and then we will have a damage. This is a one column, steel column, reinforced concrete column. You see, it is exactly under the swimming pool. You see what is the damages. What's the building age? This building is 30 years. Less than 30 years. So you are not feeling safe. So we just visited, and recently it was repaired. But it is a small column. Do you know how much was the repair? I think the repair cost something about 28,000 ringgit. To me, it's very expensive. It is a very small, but it still whole other area, it still has a problem. But this was very obvious, and the owner, when it is a car park, they didn't feel well. So insisted the management to repair. 28,000, this one, and by another, the same thing, just almost similar condition. So, but a small column need to be repaired. Okay, when this water from swimming pool is penetrate inside the concrete, so the pH of the concrete will be reduced. So pH of the concrete will be reduced. There are some indication that when the pH of the concrete reduced, and the concrete environment, which is alkaline, will be acidic. So will be acidic, and then the concrete will be in the acidic environment. So the steel rebar will be rusted. The rusting of the concrete will start when in the period when the aggressive component reached to the rebar during initiation, and when it reached the certain concentration, so it will be propagated. Common strategy for the durable design. For a durable design, talking about the durability, this concrete cover is very important. So, and this is for the develop this graph for the coastal area. I didn't see for residential building, but somehow we can understand the importance of the covering of the steel rebar, showing that if the depth of this cover increase, so the concrete structure will be more safe, can be last until 100 years. But if it is getting just half, for example, 25 millimeter, the cover is the best, maybe is normal, but to be less, so the age will be 25 years. What happened inside the concrete structure? In the concrete, when the aggressive and component go inside the concrete, so if it is a rebar, so rebar start to rust. If you see the section here, so if the concrete is porous, so water coloring, CO2 can reach to the rebar, and then the rebar will rust. I have to a bit rush, maybe my time is limited. Okay, this is a real picture of a concrete that you see there are some porosity. From this porosity, water can go inside and reach to the steel rebar. And this is a concrete picture is from one of our study in one building. That's great. It is grade 20 cube concrete, cube strain, which is you see is like inside is like a sponge, so very porous, and also some hole is inside. When the rebar, steel rebar, start to rust, so we will have a crack. One rebar can expand from if the volume can be expand by the time to up to 4 to 6 times. Means that a steel rebar, like a cancer cell, can expand. So by this expand, so we see the what happened for the structure? We have a spalling and rusting of the rebar. This is the one, what we just open up one columns, and you see the steel rebar already gone, already melted under the swimming pool. So by the time, so what we can do here, just sometimes need to replace by the rebar, and sometimes we just do reconcreting. So you see here, it is under the swimming pool again. So failure on the during the on the waterproofing system, all wet, all the paint gone already. So yes, you see how it was repaired, and then of course they have to pay for it, and as it is because of a structure part. The concrete, maybe failure on the concrete structure, maybe concrete itself is good, but we will have a crack, even a small crack. That's why in the structure part, if we have a small crack, we have to rectify as soon as possible. If we don't care, concrete itself is good, but a small crack will be extended again in the stage 3, then water, CO2, air will penetrate, and then there will be a rust here, and we lost the durability. The concrete itself naturally is porous, and from this porosity, increased component can penetrate to rust. But in bridge construction, I saw there are very strict standards. This is a bridge, is Terengganu Bridge, that I was there to delivering the special structural live concrete. I was seeing that there are a lot of the care about the quality. For each concrete truck, we had a test. But I am saying that for residential building, is there this strict supervision or checking? Really, I am just asking, for example, this is the one column, long column, exposed, and then having the another 20 floor on top of it. So, okay, this porosity after the construction can be filled by some type of we call it crystallization, but the principle is just filling these gaps by these crystals that you can see it is crystallization, the gap and void to be filled, just stop the penetration of the CO2 and the water and the moisture. So design with minimum requirements. So design with minimum requirements is, for example, to reduce the weight of the structure, we are going to use a minimum requirement. For example, in the concrete slab, 125 millimeter, we can use it. So can we make the 125 in the excellent structure during the construction to prevent any this type of the crack? I think it is difficult. Why it is difficult? I just went during the construction. This D1 is from the space between the top and bottom rebar are very important. We call it effective depth. All engineers they knew, but here this one must be checked always. So for the concrete slabs, so this space between these two layers must be checked. Must be always the check, but it is difficult to check. It is checking is easy. Sorry, but it is not easy to maintain this space based on the design. How we maintain based on the design? We have to use, for example, this spacer. I just was walking on the concrete slab before concrete works. So you see already just 2 layers already touched from the top to go down. So there will not be, you see a lot of the workers are working. So this, we don't have a space unless we provide this spacer. The number of the spacer, size of the spacer are very important. So you see there are a lot of the crack is in for 5 floor parking area. You see the typical crack. This I just highlighted here because you see the crack, the same crack will be on the top of it. We call it, one main reason is because of this steel rebar on the top went down. So there is not rebar on the top when there is not enough rebar, sufficient rebar on the top, so we have this crack. And when we have that type of the crack, so this large span floor, and we had some deflection. And when you stay here, when the car is passing, it is a shaking. So because of the many crack was developed here. And long span column, which is, I mean, like our architect, they like it. And using the special material, which is, for example, you see here, very lightweight wall are using, and they what by a small movement of the structure, so they always will be cracked. So the question is long, very large span. So yes, we can make it, but are we perfect during construction? So if we are not perfect, so we should not consider it even during the design. So to prevent it, and a special material. So who knows, for this building, maybe 20 floor, 25 floors building. So they repair, the owner, one of the owner, another 30 years, they cannot buy, they cannot find out that this very lightweight blocks. So they use a simple block or bricks. Then the weight of the structure will be increased. When the weight of the structure increase, then there will be some overloading. So we will have a failure for the future. Who should control it? Yeah, here you see the example about this channel, wrong gradients. So it must be cared about during the construction. And one maybe more in the design, I just highlight here about the color, selection of the color. You see the dark color, there is a observe the heat. And then when it observes the heat, you see this is a imaging, thermal imaging. So you see that this lighter color is very hot, and here is a cold. And you can see there is some crack on the building. Just maybe another two slide. So you see this is the floor. The temperature on the just I showed the temperature on the one concrete slab is increased from 17 Celsius in the morning to 82 Celsius. See how much is the difference? Something about 60 degrees within 24 hours. So it is that's why these differences of the temperature make crack. And yeah, this is a roof. Under the shade, no crack, but under the sun, we have some crack. So we have to have attention on the thermal stress during the crack, during the construction, during the design, and also construction. So some more crack, and repair, maybe another. I go to my conclusion. So let me, 1 minute, I explain here about this crack, these spaces controlling during the construction are very important. A space between we call it stirrup or shear links. If this space during the construction will not be checked, so we will have this crack. You see the crack, diagonal crack. This is a crack, diagonal crack. I observe a lot in many buildings that this type of the crack are dangerous. Maybe I go for conclusion. Major defect and failure can be easily prevented. We can talk a lot on that, but it is easily can be controlled during the design and construction and operation stage. Operation stage, you see the channel already is wet. So this is a functioning building, is a live building, not abandoned building. So who's come to open this blockage? So the water can go, and you see what's happening on the under this area. So during the operation, have to be careful about our building. So okay, we can prevent it. Design should consider the integrate durability. So when we are designing, we have to think about what happened another 30, 40, 50 years at the design stage. And in the for the education sector, please, in the education sector, we have to train more young generation to be more careful, to be strengthened on the practically, not just theoretically, then this new generation may come to help us and the industry for having the better building, better life for the people. Thank you.
Thank you, Dr. Payam Shafiq, for the presentation just now. Now we are open for the Q&A session.
All right, there is two questions for Dr. Payam Shafiq. The first one, I read the question first. Does this advanced concrete will be more expensive compared to the normal concrete? If yes, does this will increase project construction costs? All right, for the second question, how to implement sustainability in concrete without only depending on modifying its main material?
Talking about the cost, not much cost. We have to see the cost of the initial cost of the material itself. Maybe the cost be definitely it is because added material. So because it was added material, so of course we have to pay more, a bit more. But you have to see the cost overall for the building. If you not just cost of the construction, the cost to say just maybe something about 10 to 20% maybe can increase. Even it is more, it is logical. Why? Because your building will be durable. Being durable meaning that you will not have headache another 10 years, 5 years, 15 years. So the building function longer, durable, without later you pay for a small column repair, something about 30,000 ringgit. So to me, it is very logical. We use our initial cost if even a little bit is higher. And how we can make a durable structure? Two issues. Related to the material, we have to take care about the concrete. For example, during the design stage, one building for load bearing, of a structure for the load bearing, for a simple building, maybe grade 25 is enough, 30 even enough, sometimes 20 also enough. But because of the durability, we have to increase this grade of the concrete, because it was proven that if we use the higher grade, so it is a more durable. So we pay a little bit more, again here, because unnecessary for the stress and load bearing. But for durability, so we are using the higher grade for a durable structure. And during the construction, we have to take care a lot. We have to have a strict supervision during the construction, which is, to me, is lacking. We are lacking on that during the construction. Somehow I am involved to construction also in Malaysia for a few years here. I can see that there is a lacking on that, a strict supervision. So just one more I add, talking about the strict supervision, when during the construction environment is hot, I think is air, rain. So usually the not senior engineer will go there. We send our junior engineer. So junior engineer are confident to stop if there is something going wrong. So that's why I just suggested in my conclusion that we have to bring we have to a little bit more care about in our education system that bring some syllabuses and courses to train our young engineer more practically. Thank you.
All right, Dr. Payam Shafiq, due to the time limitation, I will read the last question. Okay. The question coming from Fatmawati from Unimap. All right, the question is, throughout your experience in forensic engineering, have you come across non-compliance with the design cases, specifically cases where less cement was added to the mixture to save costs? For example, since we know that the cement is quite expensive, in hardened concrete, appreciate if you can share the approach or technique to determine the cement content.
Talking about the defect, to me, in the design stage, there is no failure because many engineers are relying to different standards. But in the design stage, my complaint always for the design stage is we must be realistic during the design. For example, in the waterproofing, we know that waterproof will fail another 15 years. So how we design our structure under the swimming pool to be durable? So it is a design stage. That's why we need to add some more beam, column, so strengthening further, more element of the structure, so it will be more cost. So there should be a resistance from the engineer. So no choice. For the durable building, we have to do here more strength. So that's why all engineers complying the standard in the design. But the major failure, based on my experience, numbers of the building I visited, and then to be honest, I am feeling sad that why we should have this type of the failure for the owner is, to me, it is during the construction. The main failure comes from during the construction. All the detail of we receive from the engineer must be applied. But even the engineer has the best they are designed, but if not properly done during the construction, we definitely have a failure. So partially failure or overall failure, so end user will suffer. About the concrete also, talking about the concrete, the concern of this audience, it's back also during the construction. Take care about the concrete from started from batching plan or during the on situ concrete until the pouring the concrete in the site. We should not leave it just for the worker and skilled worker. Concrete is something that I was aware for. I was working exactly in the concrete technology. I am thinking that even in our education sector, we don't have much attention on the property of the material, even in the architect, even in the civil engineering. So we have to take care more about the discourses rather than always focus to the design. I hope got the answer.
Doctor. The floor would like to thank Dr. Payam Shafiq for his presentation. Thank you.
Thank you.
Ladies and gentlemen, without further ado, let us hear the next presenter from our second speaker for today. The presentation will be delivered by Engineer Ilyani Yazrin binti Abdurrani from Public Works Department of Malaysia with the title of Road Accident Forensic and Reconstruction. What did we learn? Engineer Ilyani Yazrin binti Abdurrani, the floor is yours.
Assalamualaikum and very good morning. Thank you to Chairperson. My name is Eliani Yazrin binti Eradi from Bahagian Kejuruteraan Forensik Cawangan Jalan. And today I would like to share with you a topic of road accident forensics and reconstruction, and what do we learn? For my 15 minutes of presentation today, it will consist a little bit of an introduction, road accident forensic and reconstruction, our findings and lesson learned, and then a way forward and summary. So I'm sure some of you have seen this data anywhere. That is 1.35 million deaths because of the accidents every year. And it's about 3,700 people lost their life each day on the roads. And if we count, every 27 seconds, there is one person dies on the road. It is a public health issue that involves several sectors that concern the world leader. So where is Malaysia placed in this? Sadly, Malaysia, the third place, is the highest death toll from the road accident, behind the Thailand and Vietnam. So in 2020, transport accident has found to be the fourth most common cause death in Malaysia. That's about 3.8%. Road accident tends to be a major cause of fatalities and disabilities in development country. So in Malaysia, the issue of road accident is now also regarded as one of the most serious social problem. So despite some gain from road crashes, the fatality rates on road Malaysia is considered to be very high, as it is very close to average rate among the low-income nations. So to date, Malaysia has recorded over 500,000 of road crashes per year. As you can see from the graph, it's like increasing every year. But as you can see from this another graph, the road fatality, the road fatality has slightly decreased from 2017, and with an average about 18 people killed in the road accident every year in Malaysia. Road accident is serious, as I mentioned before, serious public health challenge to this country. This also underscores the needs for effective policy nation. So the damage to road traffic caused a huge economic loss for individual, family, and a nation as a whole. And then this one is the PDRM data. From 2000 until 2018, the data still not changed. That it showed that federal roads is in Malaysia has the highest number of road accidents compared to other road categories. So did you know that there is a value for each human life in Ringgit Malaysia? A study conducted by Myros in 2018 is called a Value Statistical Life, or we call VSOL. The Malaysian government has lost at least 3.15 million for every life killed. With an average of 18 million people killed in road accident every day in Malaysia, road accidents are serious public health challenge. So every road accident, there is a factor, a unique event actually. Its causes frequently preceded by some common factor of system component. So this is the three main factor of the the three main factors category that contribute to the road accident, which is a human factor, road environment, and a vehicle factor. As a human factor, we can say that as example, human capability, limitation, physical condition, or maybe not follow the rules. And some for the vehicle factors, example is a problem for the brakes, the tires, steering, or maybe a suspension. And our focus for today, road environment and environment factor, or we call it road deficiency, such as hazard visibility, road surface, traffic control, TMP, and etc. Okay, so now we are on the second subtopic, that is road accident, forensic, and reconstruction. This accident actually can be avoided or reduced if we do understand how they are happened and what have caused them. A proper investigation and a data collection are crucial for us to understand the factor involved in identify the field we need to focus and influence on. Then we may be able to identify the cause, and then we will implement the right countermeasure and getting the right value for the money that we spend. Accident investigation and reconstruction also consists a set of procedure that include incorporating numbers of field for expertise at site, such as we record and gathering the physical evidence, site survey, and then taking a photograph, friction measurement, and vehicle damage profile. Throughout to comprehensive analysis, we do some animation or reconstruction to prepare the reports and the plan for countermeasure. So the primary purpose of a crash investigation is actually to identify in detail how many factors as possible that contribute to the crashes or accidents and the resulting injuries, which then we need to propose a mitigation measure to avoid or reduce a similar accident in the future. So there is 3 criteria that our unit has conduct any road accident forensics, which is the first one, cases that which come interest from our top management, and then the cases which involve 3 fatalities and above in one event, and then if there are any special cases interest to department such as slippery road, surface, road harm, pavement undulation, and etc. So, and of course, there is our reference to conduct this forensic, such as our Rahan Teknik Jalan, standard specs, and we also refer the GRIM guideline and also a PIAC guideline. As for our forensic investigation flow, we do have a standard operational procedure that consists 3 stages, that is before, during, and after. This, before we go to site, we need to collect the information related to the accident and route of the accident. These are the flow before we go to the site. And then this, during the site, we do some observation and some tests at the site. And then after finish the site investigation, we come to a stage of preparing the report according to the data collected. The report which included are detailed such as accident factors, the suggestion, and the improvement. So now we are going to the gathering the evidence at the scene. So at the site, physical evidence play very an important role. This evidence should be carefully observed, located, and truly documented by means of making notes and sketches, taking measurement, and photograph. So there is 3 main sources that information that usually available, which is the victim and the eyewitness, the vehicle, and the scene of road environment. However, my following presentation shall only discuss on the JKR scope, which is related to the road environment. So for physical evidence, the inspection of road surface are vitally important. Investigators should be able to visualize, scan through the area where the accident occurred. So it is the investigator should be able to recognize and interpret this damage or evidence. As you can see, the picture number 1 is the gouge mark, and the accident we call it a skid mark. So by all this, we can see the physical evidence at site. We can get the position or behavior or the placement of the vehicle during the pre-collision, on the collision, and after the collision. Or we call it the last rest for the vehicle. as I mentioned before, skid marks or any surface damage to road accident can reveal some information on how vehicle have moved during the accidents or collision. So investigators should take a measurement of this thing as earlier as possible, actually, before the marks are removed, lost or destroyed. And as you can see, for the gouge mark, the investigator must also know how to differentiate when the accident happened or when the tow truck take the car. Sometimes there is a mark also at the area. So, what do we check on the road features? Actually, there is an 8 road characteristic that we can need to be checked on SS. First is the road layout, as a side distance, horizontal curve, super E at the curve. We also evaluating the placement of the or the configuration of the junction or intersection, and then the road profile. We're checking the vertical alignment and the side distance. The number 3 is road cross section, which is we check the road cross slope, the width of carriageway, the shoulder, and we also identify the road surface types and drainage channel. And then there is a road side objects to identify and placement the rigid object, including the traffic barrier. And number 7 is a road furniture, where is the performance quality of the road sign, the road marking and delineators. And then lastly, we check the road surface condition, which is the skid mark properties, texture depth, pavement surface defects such as pothole and undulating pavement surface. So, and as a accident investigation should be adequately trained and well equipped with a proper camera for taking photograph and equipment. So these are for the assessment on the road features. We have 2, which is a visual inspection and data collection. The visual inspection, we check on the road surface condition, which is road rutting texture, maybe cracks or any pothole that might be linked to the accident. And also, we check the drainage system. As you can see from the picture, it's quite dangerous when the we call it road shoulder are not maintained properly, because there will be stagnant water or water ponding. And then from the third picture, I think some of you can be guess what is the problem. The water is not flow correctly. Maybe it's a super E is we call it terbalik lah. Okay. Next, the data collection using the tool. And of course, what is a complete investigation without a proper tool? So, what are the tools that we need for the road accident forensics? These are the data collection for the pictures and videos for the accident. We have a drone to take the clear situation at the site. And then we have a true pulse meter. This one is for checking the side distance. Using this true pulse meter, we check the minimum stopping side distance for the safe length required for vehicle to safe travel and to see something in front of, and to make I think a safe decision to stop before reaching that hazard or anything. A side distance actually a sum of total response and reaction time and also break time. These are the reference for the side distance. Example, for 90 km/h at our federal road, the minimum side distance that we need is 160 meters. And then we collect the super E. That the function of super E is actually to balance and prevent the vehicle from overturning or slipping, as well as provide comfort to the driver lah. As you can see, this is a super elevated curve where this from a normal crown, and then there will be a transition where there is a full elevated super E section. We measure the super E using the same device that is a true pulse meter. And then these are the reference for the Super E value. You can refer at the ATJ 885, table 4, 7A, 7B, and 7C. And then we also check the cross slope, or some of us call it scamber. As a cross slope, its function is to provide water to flow to the side of the roads. Is to avoid the water ponding, which can, if there any water ponding, it will be an aquaplaning, which is dangerous to the small vehicle. These are the value for the normal cross slope is about 2.5%. We also take data of a spot speed, we call it spot speed, where the speed limit average at the road user, we take about 30 data, and then we do a graph, and then at the 85 percentile, that is the, we call it an average of speed that vehicle along that road. This spot speed data can be performed on straight or curved road, but and then do not perform this during peak hour or any during raining or bad weather, because it will affect the data. This is how we plot the spot speed data from this. Actually, it's from PIAC, and then this our 30 data minimum, or you can take more, is better, to determine the spot speed data on the 85 percentile. So next, we also take the advisory speed at curve. You know that at curve, there are certain speed that when you drive, you will feel like comfortable. So to get this data, we drive at a comfortable speed for 3 readings for a different speed limit. And then upon arriving at the bend, the maximum reading of the ball bank is taken. This, as you can see, is the ball bank. This one actually is the same. This one is an electronic. The one is a manual one. So the safe speed is obtained using the ball bank angle versus the advisory speed, which is this one graph. So when you plot this, you will get the advisory speed for that particular curve. And then we also check the road surface condition. The skid resistance, as a first picture, taken using a British pendulum skid. It's a force, actually skid resistance is a force that develops when a tire that is to prevent from rotating slide along the pavement. Skid resistance is actually important parameter in pavement, because if inadequate skid pavement, it will lead a more slippery accident. And then there is a minimum skid resistant pavement surface. For our roads, is we call it SRV. It's a 45 SRV. Then we also check the mean texture depth. This second picture is how we collect the data. If the data is more than 50 mm, rainwater can flow. This is not can. Sorry, this one type of error. It can flow to the roadside. It means it's good. Next. Okay, after we get the skid resistance value and the mean texture depth, and then we can get the skid number, which is this graph made by the Unit Forensic Keselamatan Jalan on 2011. That is found that if SN value is greater than 24.5, the pavement is a good friction due skidding. An accident can be avoided. If less than that, there may be a medium risk of accident due to skidding, or high risk accident because of skidding. So next, we also measure the rate of light reflection on the signboard, because a signboard is we call it a visual language that represents some special circumstantial information of the environment. So we collect this data using this Zentner reflectometer, the model of ZRS 5060. The signage guideline you can see is the value of the reflectivity varies depending of the type of the sheetings of the signboard. There is a high intensity prismatic sheeting and also a wide angle sheeting. This one you can refer on ATJ 2E/87 for the guide sign design and application. And then we also collect the data for the road marking, which is the width, the thickness, and the reflectivity. For the reflectivity, we're using also the Z, but another model that is ZRM 6013. And as you know, I'm sure all of you have been drive or in a car, that road marking are particularly important, especially at nights condition where the amount of light available are limited. So the reflectivity of the road marking is important to guide the driver. And then these are the guideline or the value for each for the road marking, different from the during the dry condition and the wet condition. And then these are the what we call it width 2.5 to 5 mm, and then for the thickness are 100 mm. And then we also collect the data of the cross section, the width of the road. Okay, next, we do have a standard form for our accident scenes investigation, which is the background of the area, the value that I have said before, the test. We have this standard format. These are, I just show to you. What is the form? Okay. Now we are going to the analytical tools for accident reconstruction. So all the available evidence that we collect before must be analysed, correlated and interpolated to determine how the accident had happened. The analysis including the data processes, evaluating possible hypotheses, creating models, recreating accident, or we call it reconstruction, and that may involve a simulation using a software. So this is what we do at our office. We have this three software, which is Autodesk, the Google Earth, and SketchUp. This combination of output from this software can help the investigator to do the post measurement. Okay, this one of the example how we do the accident reconstruction using the SketchUp. As you can see, this is a lorry and this a car, and how the event had happened. This we call it time series event. This using a SketchUp. And then these are the same one. This one, as you can see, this one at the straight road, and then this one at the curve, how the accident occurred. And this one another example where the accident occurred at the junction. It's all using a SketchUp program. And then this one is we call it defect mapping. Also, we can use it using an AutoCAD, where there is a location of the last vehicle rest, and then a gauge mark, and then we have a skid mark for the trailer, and for others marks. And also, as a simple program such as Excel also can be used to do the distress mapping at the accident area. These are the example. For data collection, we do the radius at curve using the AutoCAD desk and the Google Earth, which is this one can be determined the exact radius at the location prior to the accident. As you can see, these are the example. This one using the AutoCAD, where we draw, we copy the Google Earth and then we draw it, and then we get to know what is the radius of the curve. So this one, the drone picture, we use our drone to get to identify the layout of the junction to get the clear flow of the traffic. Because as you know that Google Earth is not sometimes it's not to update. So when we do we have this data, we have the clear picture and the real data for the road accident. Next, this is our new baby, the Agisoft. This Agisoft can done a 3D modeling for the accident area and also can do a mapping for that particular area. And when we have this Agisoft, we also hope in the future we can get the PC crash software, with this PC crash software is a complete simulation of the road accident to have a better data. So as I mentioned before, PC crash is actually a collision and trajectory accident reconstruction software. When we have this software, is to get the better simulation, which event that demonstrate the consequence that leading to the crash. And in the simulation package, 3D features are applied in the reconstruction of the accident process. Oh, sorry, before that, I want to mention, with this Agisoft also, we can, if there are any problem, we cannot get the measurement at site, we can do this measurement using this software also. It's made a lot of things easier actually. And we call it, the raylet of this Agisoft are only about 0.1 meter. Okay. Next, we go to our findings. Our findings are throughout from 2008 and to until 2020s. What we have done in road forensic accidents. So we have produced about 264 reports for road accidents. Actually, our unit also produced another report about a black spot area, pavement forensic, and then hydrology forensic. So this only 264 only for the accident forensic. So what we get from this 264 data report, sorry. So majority of the vehicle that involved are cars, which is 56%, followed by lorry 19%. And then there is a time of accident, which many of accident happen during the day and the environment is sunny lah. So maybe there is also some glare problem where the sunrise or set that may cause the accident. And majority of the accident also happen on the good weather. Maybe the driver tends to have a good, safe and comfortable driving on a good day. Maybe they tend to speed more. So where the accident mostly happen, on the straight road about 51%, followed by curve about 37%, and the accident occur at the intersection about 12%. Majority of the crash, about 117, happens at the type of collision because of the out of control. As we know, out of control sometimes caused by the overspeeding. And then there's head-on collision. Head-on collision often occurs between the vehicle from two opposite direction. Actually, this type of collision is among the most dangerous because the force of impact multiplied due to the travel speed for each vehicle. And then we go to our main focus, the road deficiency. For the top three, the first one is the signage and the road marking. The deficiency in the traffic signage can result in inappropriate driver response, which has an impact to the traffic system. So the second one is the road safety facility, which is 15%, followed by the pavement defects, surface defects, about 11%. Then for the spot speed, we found out that 60% vehicle are failed to follow the speed limit at the accident location. Speed actually plays a major role in serious injury that caused by the car accidents. Not only because speeding causes crashes, but it also can make accident worse when they do happen. And then for advisory speed at the curve area, 55% the advisory speed are not provided at the critical curve. Sometimes people tend to drive the same speed when from the main line throughout the curve. So there is not enough traffic calming device, or not. We don't have any advisory speed warning before reaching the curve. So did you know there is a difference between this signage and this signage? Okay. Can anybody take a guess? Okay, in the comment, Facebook. So do you know there is there actually is a difference between these two ones. The black one, we call it the black over yellow signage, is a speed advisory sign, where there is often mistaken for the warning sign, which is the the black over red, which is the warning sign or mandatory sign. So the warning sign is a regulatory or prohibit signs, and it placed within the speed limit zone, which is while this advisory speed limit is actually just the advisory speed for the warning sign, so that you drive at the area, you will be more safe. Okay. Next, for the road surface condition, overall for this result shows that the road surface are satisfied, that which is the water can flow through the pavement, and then it's not slippery. So our finding, as I mentioned from the donut chart before, these are all our road deficiency that from our forensic finding throughout the 2008 to 2020. So this road deficiency is a component that might be a contributing factor to the accident, beside the human and vehicle factor that, as I mentioned earlier. So this one, I just show you some of an example that common we use to see at the side lah. So this one is the road profile, or the geometry of the road, is the road deficiency that resulted by the inconsistent design speed. The problem at the area, because the side distance, some of the driver tends to overtake the lane, even it have a short straight lane. Overtaking opportunity is a very risky, which will result a head-on collision. Then the next one is the road layout. As you can see, this one is a quite hazard, where is the U-turn are located at the curve. There might be which is the side distance issues. When people want to make a U-turn, they cannot see a approaching car in front. And then we also found this common example. Malaysia is a unique country, so we have many unique intersection. This one example. It's a common example in our road, which is a hazard. The issue is, as you can see, the B. You can see this, a B car. Actually, it's come from the main lane. Suddenly, he or she has to go to the second lane, which is quite dangerous. Some we calling this term trap lane. And then also we have too many junction here, also quite a hazard. So we need to do a proper channelization over here. And then these are also a common site, where the intersection are located at the crest of the at the crest, or at the crown. This also will create a side distance problem, which the driver cannot see the approach vehicle before he or she can cross the road. Please remember that all the picture that I show to you, where is the 3 death has happened in one event. Okay, and then this the cross-section problem, where as you can see this picture, there is additional lane at the downhill area near the bridge. So it's quite dangerous because the the additional lane is also quite short. And then this one is, as we call it, not enough the width, the carriageway. So when vehicle pass side by side, it tend to have a side swap collision. So this one, as I showed before, this an unique intersection. Maybe at the rural area we have found this many because of development. So there is additional lane, sometimes additional junction. There is a problem, especially this one. The first one is the X junction. Some of the people, when we interview, they didn't know which is the main line priority, who is which we call the main line. So we need to do a proper channelization. This one same problem issue. So this one road shoulder problem. As you can see, there is a tire of a heavy vehicle. It shows that the narrow lane, this narrow lane, will cause a difficult maneuver for heavy vehicle, especially at curve. Actually, heavy vehicle tend to steer by swing or correcting their, which often result in encroaching into the opposite lane. So paved shoulder is actually should be a long-term solution to reduce the accident rate. So okay, this one is a poor maintenance work. A problem with the side distance, as you can see this one, the third picture. This is important actually because when, especially at curve, we need to have a clear view for this area. And then another poor maintenance works, as I mentioned before, not proper grading at the road shoulder. It should be maintained properly because the vegetation will grow and then it will prevent a proper outflow surface water with result ponding. When there is a ponding on the road, they may cause an hazard for vehicle. And also this one is the pavement defects. Some of the shoulder we have a edge drop more than 100 mm, which is quite dangerous. The Super E, as I mentioned, this one is reverse Super E. We calculate, we measured all the Super E. Some of the cases where the Super E is reverse Super E, there an accident that will occur because of oversteering. Then, of course, we have this poor condition of traffic signage. The reflectivity, some are not okay. Then the material also are not following this the spec. The sign is actually necessary for to inform the driver about the something ahead, such as uneven pavement, a sharp curve in the roads, narrow shoulder, etc. Then we have a road marking. We have some are insufficient number, some are already faded. Some of the road marking is not clear, and then as you can see, this one is quite weird. Where is 1, 2, 3, 4, 5, 6 road marking on here. So we hope that when in the future to reduce all of this matter. And then this a common, what we call it, a common wrong application of transverse bar. As you can see, transverse bar should not be along until the road shoulder. This one, as we found. And then this one, common in KL. You can see the transverse bar are placed in the curve. Actually, we cannot do that. Yellow transverse bar should be placed 30 meter before the approaching the curve. We do have a standard for the transverse bar. These are the standard where you can find it on our manual facility Keselamatan Jalan. And then we have found this one, the road safety facility, that wrong placement also. When you have a double line, you should put this road start side by side. And then this one, a single amber light, we call it. Amber light should be placed on top of the signage because we don't know what is this amber light indicate for. And then there is a traffic barrier which is not suitable or is hazard to the user. So what is our recommendation? These are the common recommendation by us for each road safety issue. I just go through this. Some other road hazard, change all the rigid, if any rigid electric pole, to change to the frangible poles. And then for speed limit, to control the speed limit at that area, we can install a traffic calming measure or for the speed management, such as the yellow transverse bar, advisory speed, or the road hump. These are the example of our countermeasure drawing, where we put the advisory speed, the advance warning, the transverse bar, and the channelization of the road. These are at the intersection. Example, and this one example at the curve. We put the chevron, advance warning, and the transverse bar to slow the traffic. So we decide on low countermeasure. There's somebody, Philip Jordan has said, spend $1 for black spot treatment, return $4 in cash serving to the community. But remember, one size does not fit at all. There is much judgment in every solution. So as a way forward, accident investigation and reconstruction involve the inspection and evaluating of the system component that consists human, vehicle, and road factor. So there is many data collected that we need to be done to determine the physical evidence to be gathered together on a relationship for all these factors, that including to conduct some performance tests. So the whole process, this consists of a set procedure that incorporating many field as expertise. We need to have a comprehensive collision analysis, including the simulation. So the benefit of such as in-depth analysis provide a reliable base for the reconstruction of an accident and allow better understanding. So these are one of the systemic approach to safety to prevent crashes before it occurs. And then we do the optimization safety benefits. And then we have a leverage in-house resource for the maintenance or the consistency. And then we also improve for the future planning. As JKR, we have implemented the proactive and reactive approach. As forensic investigation accident, we are at the reactive approach. So innovation, as you can see, some of countries have produced this maybe this innovation as to guide or to make toward a safe road. Some are the musical road, as you can see in Japan, US, or Denmark. These musical roads not only for entertainment, but it's also to reduce the speed at the area or to alert something at the area. And then there is a wireless traffic sign where you don't need the physical traffic sign. You just have install it in your handphone or apps. You can alert from that, so you don't tend to look outside. And then a smart street light. I think I'm not sure we already have this one, the solar one, and then the smart delineation. These are an innovation that we can use to improve our road safety. So for the summary, road safety engineering is the last safety net when enforcement, education, and publicity has failed. We have a responsible to investigate thoroughly, to spend fund wisely, and to protect all the road users. And then there is only mistake in life if the lesson is not learned. With that all, I thank you. And we belong to Allah, and to Him we shall return. Al-Fatihah to all the victims of the road accident. Thank you.
Thank you, Engineer Eliani Yazrin binti Abdurrani, for the amazing presentation just now. Now we are open for Q&A session.
Okay, there is one question from the audience. Okay, the question is, in your opinion, is VMS suitable for use in the maintenance or road safety of JKR roads to adapt to IR 4.0? VMS. Vehicle Management System.
Vehicle Management System. Yes, we do need that. Actually, when we have VMS, we will have a better collection of the data in terms of in the mapping of all the defects. Actually, I think the CF, the Cawangan Senggara facility jalan also towards this technology.
Okay, if there is no further question, thank you. Engineer Eliani Yazri binti Abdul Rani from Public Works Department for the Q&A session. Thank you.
Dear ladies and gentlemen, we are now going to have our morning tea break until 11 a.m. Please note that after the coffee break at 11 a.m., we will continue with the next speaker's presentation. Thank you. Ladies and gentlemen, let us continue the session with the third speaker for today's seminar. The speech will be delivered by Professor Engineer Dr. Raizal Saifunas bin Muhammad Rashid from University Putra Malaysia with the title Chemical, Non-Destructive Test and Residual Capacity Evaluation for Deteriorated Reinforcement Concrete Structure. Without further ado, please welcome Professor Engineer Dr. Raizal Saifunas bin Muhammad Rashid to present.
Okay, thank you to Mr. Chairman. Assalamualaikum and good morning to everyone. First, I would like to take this opportunity to thank the organizer, Center of Excellence for Engineering and Technology, CREATE, JKR, for inviting me to be part of this seminar. My name is Raizal Saifunas Muhammad Rashid, and I'm from the Department of Civil Engineering, University Putra, Faculty of Engineering, University Putra Malaysia. My title today for this seminar is Chemical Non-Destructive Test NDT and Residual Capacity Evaluation for Deteriorated Reinforced Concrete Structures. Before I progress further, I would like to take this opportunity to thank two of my master students, master by coursework student, who is IR Siti Norina binti Muhammad Yusuf. She is a senior civil engineer bahagian jalan JKR Negeri Sembilan, and IR Muhammad Sainuzi bin Abdullah, civil engineer bahagian reka bentuk jambatan cawangan jalan, and which both of them did this study as dissertation to complete their Master of Structural Engineering and Construction in UPM. IR Siti Norina contributed to the Chemical and Non-Destructive Test section, while IR Muhammad Sainuzi is on the Residual Capacity Evaluation, which is very much related to the IR 4.0 in overcoming the challenges in forensic engineering to estimate the beam capacity with corroded steel. As mentioned, this presentation is divided into two parts, which is focused on the chemical non-destructive tests and residual capacity evaluation. Each topic content shown here, which is the introduction, literature review, methodology, result and discussion, conclusion, will be explained and discussed comprising these two main scope of the study. So now we'll start with the introduction. Deterioration, whether with physical or chemical process, will lead to subsequent failure of the structures. Common structure deterioration such as scaling, delamination, fluorescence, cracking, spalling, and corrosion are influenced by the environment, exposure, and chemical attack. Structural condition assessment for concrete structures has been for many years by visual inspection, non-destructive tests, and destructive tests to examine the internal and external reinforced concrete structure condition. A case study of building condition assessment of Cawangan Traffic and Jabatan Siasatan Jenayah IPD Tampin Negeri Sembilan was conducted with sample taken from testing based on the chemical and non-destructive tests to identify the cause of deterioration. This assessment investigates with series of tests carried out on the building to determine the root cause of the deterioration. So conditions of the existing reinforced concrete structures due to duration are also an often problematic issue for many countries, including Malaysia. To maintain serviceability of the building, government needs to allocate millions for the maintenance and rehabilitation works. Basically, most of the severe deterioration problems are when it is associated with the corrosion of embedded steel reinforcement. Based on the previous research, carbonation attack, chloride ingress are the major causes of corrosion embedded reinforcement bar. Corrosion product can expand more than its parent steel. The primary effect of embedded steel corrosion, first is loss of bar cross-section, where it can be local pitting or general average corrosion. Secondly, weak interfacial layer due to the corrosion product that does not have the strength. This condition will reduce the bond between the concrete and the steel. And the third is the volumetric expansion of corrosion product will exert pressure to the surrounding concrete and finally results in concrete cover spoiling. All of these consequences will reduce the load carrying capacity of the structure. So here are the literature review for the chemical and the NDT tests that were referred in this study to conduct the study. Most of the papers are discussing the test for detecting cause of concrete defect. So we have here the 3 papers was referred, and also another 4 which conclude as 7 and more was being done throughout the study. Next is the literature review for the residual capacity evaluation. Here we have papers discussing the best model and methods to calculate the residual capacity. And from this information, all were being used in the study to get the residual capacity of a corroded beam. Right? Then we go to the problem statement. So as I mentioned just now, an assessment was conducted on the deteriorated reinforced concrete building, IPD Tampin. This building was built in 1982, was used approximately in 1985. Existing building was a quarters for officer in 2013 and was renovated by the PDRM as an office building later on. So the building has shown significant distress on beam, soffit slab, column structure due to the corrosion of steel reinforcement and cracking of the soffit slab. The visual inspection shows falling delamination in beam structures that contributed to the steel reinforcement corrosion. Cracking was also observed on beams, slab, soffit, cracks due to bending failure was also found. Assessment of the building was conducted based on the garis panduan pemeriksaan penilaian keadaan bangunan sedia ada. The structure severe deterioration was found at level 2, 3, and 4, with further investigation is needed to find the causes. However, only level 2 and level 4 were accessible for the study because level 3 was restricted to public. Often designers and maintenance authority disregard this complex issue of deterioration problems. The deterioration will reduce the structure capacity, load carrying capacity, reinstating the structure member by rectifying through repairs and center works may not regain the distressed structure. Wrong undertaking of the solution may lead to temporary fixed problems and cause the problem to reoccur again. Underestimating the residual strength of the beams or structure members that were severely deteriorated may pose danger to the structure's serviceability condition. Therefore, the needs of looking into degree of the degradation that reduce the load carrying capacity of the member related to the corroded steel reinforcement are essential before any remedial works take place. But these are the steps that were considered in the study. So these are the objectives. As I mentioned just now, the objective for the chemical and NDT and residual capacity evaluation was combined. And with that two section combined, we come to six numbers of objectives. So the first objective is to assess the structure condition of reinforced concrete building to provide defect mappings and rating based on the guidelines. The second objective is to conduct a laboratory testing based on the chemical and non-destructive tests from the concrete field sample. The third one is to identify the effective methods of assessment, structural condition from chemical and non-destructive tests. The fourth is to investigate the integrity of serviceability of the structure based on the testing provided. Number 5 and number 6 is based on to find out the residual capacity evaluation and use finite animal model to analyze the structure. The scopes of limitation of this work is field testing and laboratory testing conducted based on selected non-destructive tests and chemical tests. Only accessible areas are taken, with some areas are restricted to public, which is, in this case, is level 3. No supporting documents such as as-built drawing, inventory cards, maintenance, repairing reports, because of the existing building was built more than 40 years old, and early documentation may have been disposed. No reliable reading from the Department of Meteorology for relative humidity reading because the authority reading located 20 kilometers away from the location. So the fifth scope and limitation is that inclusive to perform BCA on the existing buildings and crack mapping of the deteriorated beams. The reinforced detail shall be estimated using rebar locator, which is the sixth limitation. The concrete strength shall be evaluated using both non-destructive and partially destructive tests using rebound hammer and compression tests. The corrosion degree was estimated using vernier caliper, and this study only performed FEM to the selected beam that was severely deteriorated, which is excluded from the global analysis of the structure, which means only severely affected beam is being analyzed. So the methodology for the chemical and NDT test is divided into two phases. The first phase is the preliminary assessment. So assessment at site begins with summary report recorded using JKR form shown on the slide. The primary information shall consist structure number, structure name, owner of the structure, year built, and the status of the structure. Next is the building detail that should have type of building structures, building use, numbers of level, building design, and building supervision. Also related documents such as operating manuals, operatings and manual procedures. And next is the defect information, all defect or damage information by structure component, and the summary report, which consists the rating, major damage description, and necessary repair maintenance suggestion. So visual inspection are usually conducted on the field assessment before the field test is performed. The inspection must review preliminary result based on the visual inspection before any findings. In this study, the field test covers surface hardness test or rebound hammer, coring, in situ carbonation test by spraying phenolphthalein solution, and measuring relative humidity test. There are two rating criteria applied in JKR VCA. As you can see in table 1 and table 2, which is the primary assessment maintenance and also building physical condition level. A 5-point scale represents each defect severity, and the scoring represents numerical rating of 1 to 5, which means 1 is the optimal condition and 5 is the critical condition. Hence, analysis of the defect finding links to the defect parameter for the building condition and maintenance priority action level shown in the matrix in table 3 and also in table 4. This will be discussed in detail in the next coming slide. So now we start with the methodology of the field assessment. So number one will be the visual inspection. Assessment structure measurement to identify the distress on structure element based on DCA. Due to the incomplete information such as built drawing, on-site measurement need to be implemented to obtain defect mapping plan of the building. All accessible component structure implemented dimension measurement, including building area, height of the beams, column structure component, slabs, and all fittings component. A grid of 1 meter line was marked on the structure to map the defect. The position of the defect and the sample recovery point had been mapped. The evaluation also involved measuring the diameter of the reinforcement bar, the depth of the spalling concrete cover, and the crack width also recorded using crack comparator. Next is the site measurement for defect mapping. So we identify the deterioration occurs such as spalling, delamination, and cracking. Next is to record relative humidity and temperature using LCD digital thermometer air temperature humidity meter. The reading was taken every hour starting from 8 a.m. until 5 p.m. at level 2 and level 4. Reading taken at different IPD building location to measure relative humidity reading effects and compare with data from the meteorological department. Next is the rebound hammer. The sketches are drawn at the structure element to identify the most suitable area to conduct the testing in order to develop the contour of the concrete quality of the structure. During the test, 9 readings will be taken on each location to estimate surface hardness. The reading shall be limited to an area not exceeding 300 mm by 300 mm. And we have here the coring test. Solid concrete have been taken from coring prepared for the laboratory test and the field test. Then we have the phenolphthalein spray. The phenolphthalein indicator used at site to determine the carbonation depth in concrete by spraying phenolphthalein solution to the surface of the concrete. A specimen in nano-cobaltic pipe turned into purple red, here as shown in the diagram, or in the picture, where the concrete was still strongly alkaline. Sample may be in terms of coarse, fractured piece or drill. Then also we took powder for the unsound concrete. What we did was when the test, the specimen is being taken from a drill hole, and the dust was extracted from the hole using an airbrush. Then the uncolored layer depth is measured at 4 or 8 position as an average. The concrete color will change to purple if the concrete still maintains its alkaline characteristic. If carbonation has occurred, and there will be no color change at all. And the last field assessment that we did, or the method that we used, is to identify the resistivity test. It's according to H2 T5815, is to indicate the concrete ability to resist chloride ion penetration. This test has been done using 4-pin Werner probe array to measure the resistivity of 200 mm nominal length and 100 mm nominal diameter cylinder cores by applying alternate current AC potential to the surface resistivity apparatus at the outer pins of the Werner array to generate current flow in the concrete. The resultant potential difference between the 2 inner pins was measured to calculate the resistivity of the concrete in kilo ohm centimeter. So that is about the methodology of the field assessment. Next, we go to the method. This is the summary of all the things that I mentioned just now. And now we go to the second phase for the chemical and entity tests. So the first one I mentioned just now was related to the field assessment. Now we go to the laboratory testing. So we have all these 5 testing that we will do: the pH testing, the scanning electron microscope, SEM, X-ray diffraction analysis, XRD, Fourier transform infrared spectroscopy, thermographic metric analysis, TGA. So I will explain each and one of the laboratory testing to make you all clear about what it is about. So for the pH testing, in this study, is going to use EU instrument pH meter that is available at our lab. The sample is prepared 1 part of the concrete powder, which is 20 gram of concrete powder mixed with 1 section of distilled water, 20 milliliter of distilled water at a ratio of 1:1, and then apply the pH electron of the pH meter to get the reading. So here is the pH test equipment. Then the scanning of electron microscope, SEM, identify the microstructure morphology of the minerals and characteristic of the solid concrete. Also can capture images from the cross-section of the concrete specimen. Next is the XRD diffraction equipment or test, which is it distract or diffract powder that have been used to identify the mass fraction of different crystalline phases in the concrete. XRD is the great qualitative analysis in identifying minerals and sensitivity to small structural changes. Then we have the FEIR, or we call it as Fourier transform infrared spectroscopy. This method is to determine the functional group present in the molecule. Basically, FTIR spectrum is a fingerprint of the bonding which appear in the chemical, and it is useful for identification and for quality control purpose. The next is the TGA. This is the simplest method to quantify the calcium carbonate resulting from the carbonation, and is also commonly used. This method is intended to calculate the extent of quantitative profile represents as quantities of the chemical phases in the concrete specimen at various depths. This is the summary of laboratory assessment, and we continue the same thing on the next slide. So now, what I have explained just now is on the methodology that related to chemical and entity tests in this study. Now, I would like to discuss further on the methodology for residual capacity evaluation. So this, for the residual capacity evaluation, it has 3 phases, or it involves 3 phases. So the first one will be to conduct the BCA as shown here in the slide. And with that, we validate with the whatever data that we get from the BCA. It is being validated with the FE model, with experiment data from previous researcher, and develop the FE model for case study and perform the analysis. So that next is the visual inspection. Was performed on the existing building to find the deterioration problem, and any distress found will be recorded and rated based on the severity of the problems. Only structures that score between 16 to 25 in BCA will be further analyzed using FEM. So only severe structures will be analyzed in this residual capacity evaluation. So validation of the control beam. A researcher paper, Lechemi et al. Was used and the beam configuration as shown in this slide. The FE model was developed step by step as shown. After obtaining the similar result, the experiment data, the selected model will be used as base to model the corroded beam. To continue with the modeling of the corroded beam, this study also performed match sensitivity analysis to find the suitable mesh size adequate for this study. Next is the material properties and behavior for the concrete. To model the nonlinear behavior of the concrete in Abacus, this study used the CDP model, which is the concrete damage plasticity model. And in the table here, it shows the parameter that was taken and used in this study, such as the Poisson ratio is 0.2, which is recommended by the CEP FIP. The rotation angle PSI is assumed to be 38 degree. The flow potential eccentricity epsilon is taken as 0.1. The initial eco-biaxial and initial uniaxial stress ratio is 1.16. The second stress invariant tensile meridian is also 0.67 and the viscosity is 0. The stress strain curve of the concrete is determined using the stress strain relationship as suggested by the SEN 1992. In the concrete damage plasticity model, the plastic hardening strain in the compression played a key role in finding the relationship between the damage parameter and the compressive strength of the concrete, as shown in figure 3.11. For the concrete tension behavior, the modified tension softening curve proposed by Salam et al. Have also been considered in this study. So the material properties and behavior of the concrete. So this is one of the examples of the concrete properties used for the study, which is grade 40. The stress strain curve for the compression behavior for the inelastic strain curve and tensile behavior of the concrete grade 40 was selected for at this stage. So validation for the corroded beam. Validation process of the corroded beam, the experiment data from Rodriguez et al. Was used to develop the FE model. The modeling steps quite similar with the previous validation, except this model involved the reduction due to the corrosion applied at the concrete, steel, and bond between concrete and corroded steel. After performing the analysis, the load deflection curve was plotted. So modeling of the case study beam. So before progressing to the corroded beam steel model, the data collection needs to be done at site, including crack mapping and also beam distress. Besides that, the data needed to do this model is the concrete strength test, evaluation of the corrosion degree, and testing for a result for the carbonation and chloride attack. So with all this requirement data that we have, the complete FE model will be modeled and developed. The FE model developed steps similar to the previous model, but with actual deterioration beam condition. The modeling is including the development for the perfect beam. Perfect beam model will validate with the calculation section capacity of the to ensure the FE result is acceptable. The FE model is also performed for the actual deterioration condition at site, which is the corrosion occur at the tension reinforcement and stirrups only. This study also investigates the influence of the corrosion at compression reinforcements. So the FE model of all corrosion, which include corrosion at top and bottom reinforcement, is performed using the same degree of corrosion for top and bottom. So with that, all relationship is being considered. The reduction capacity was estimated from the FE model and also previous study data. And this will eventually estimate the ultimate collapse load for the case study of the beam. So that is about the methodology. Now we go to the result and discussion of this case study for the IPD building in Tampin. So if you see, I tried to arrange, or this slide arrange in a manner that it will mention what are the objectives that the result will try to fulfill. So for this pictures that I've taken is to provide defect mapping and rating condition, which is under the objective number 1. So as you can see here, that figure number 1 is the deterioration at second and first floor, block B IPD Tampin. So what it means here is that this is considered as on the first floor, because this is the roof part of the first floor of this building. And we have here a few deterioration that you can see on the second floor. Next is the deterioration at level 4 at block B. These are all the pictures that were taken, and credit goes to the students on how they managed to take all these defects with very small space area to take all these pictures. There we have the figure number 3, which is the deterioration or the defects at third floor on this particular building. Okay, with all these figures, we managed to come up with the floor plan, and this is still under to fulfill the objective number 1. So here we have that several distress was found, and on each floor plan, there is an indicator that we show the RB, which is for the rebound hammer test, and the core, which will indicates the coring test location. So at level 1, there's not much of a distress was found. Only longitudinal cracks and joint cracks were found, and also a small area with watermark or stain. Next is the second floor plan. Here, what was found was longitudinal cracks, and we have also spalling and corrosion. Rebound hammer test was conducted in this area close to the most defect or most distressed beam. And this is a B2 beam, which I will explain later on what does it means. And this is very useful information or location that where the finite element model was conducted on analyzing the residual capacity evaluation. So here we have the coring location at the second floor. So next is the third floor. As you all know, the third floor is restricted to public. However, there are still longitudinal cracks, and also spalling was found at the grid line number 1 beam, and that is as far as where we can go at the third floor because of the reason that I mentioned just now. So this is the fourth floor plan. Here we found a few type of distress. We have corrosion and spalling on the floors. And this is a location of bilik taklimat, where there is a location where rebound hammer is being conducted here. And there are also coring tests was being done in this beam here between grid line 1 and grid line number 2. So the beam selected for the FE analysis is B1 beam, which is located here. So from there, what we come out and what we collected the data is to perform a table of building condition assessment, the BCA, and from there you have the metrics where you have few values rating that was concluded here, and 11 distress was found on the building. The reason of only 11 is that we only find the most severe problems. Out of that, and only 2 required FEM for further analysis, namely beam B1, which is this one, which is located at level 4, and B2, which is located at level 2, with the overall score of, with the score of 16 for both beams. So which means that based on the physical condition level and assessment maintenance action, so these 2 beams are considered as severely deteriorated. So that these 2 beams require repair, and these are the selected beams for the final element analysis. So these are the summary of the BCA that was being used, and as a conclusion that we can make from the BCA is that it needs urgent or immediate repair, and also it is the priority for the building physical condition is fair. So these are all the metrics being calculated here, down here for table 6, and this is the overall score for the beams at this particular building. So now we go next to the objective number 2. So we conclude, we finish achieving objective number 1. So objective number 2 is to conduct library testing on the chemical, non-destructive and non-destructive tests for the concrete field sample. We have relative humidity and also the rebound hammer. So here we found that most of the readings are between 70 to 80%. And with that 70 to 80%, it can say that carbonation tend to occur at this range, where we can conclude that one of the reasons that the beams deteriorated is due to the carbonation effect. And then we have the rebound hammer. So from here, we can see this the rebound hammer reading that we have for sample 1 until sample number 4. And for the carbonation cases, from the result, the reading of the rebound hammer can be up to 50% higher than the strength of the concrete in the uncarbonated concrete surface. So basically, these are all the readings that observed during the site investigation. Now we go to the still on the objective number 2, which is on the phenolphthalein spraying. So after spraying the phenolphthalein, it seems like the 2 cores on level 2 concrete cores that was drilled and extracted from the beam. We can see that 45 mm carbonation was found on these 2 cores sample, which means that they shows the reduction of alkalinity for this concrete, and the rest of the depth of the core is turning to purple, which means that the sample is not carbonated for the rest of the depth. So then we go, the same thing also occurred on level 4, that the coring specimen 45 mm is carbonated, and while the rest of the depth of the core is in pinkish color, which is uncarbonated depth. So then here we have the pH test. The pH test found that the highest pH to be 10.89 for the core sample, and 10.69 for sample 2 at level 2, and 10.89 for sample 4 at level 4. And that is for the core sample, which is the, or we call it sound sample, which is the core concrete. While for the unsound concrete, it is between range of, sorry, it's the other way around. The pH for the sound concrete is between 9.5 to 11.5, while the unsound concrete is between 10.96 to 10.89. So the resistivity test, which is to identify the specimen to chlorine, the resistant or to chlorine ion penetration. So it seems here is that the average is 19.3 as shown in this table. Moderate in chloride ion penetration for sample 2 and sample 3. The average is 31.2 and 22.7. So the result clearly show that there is no involvement of chloride ion in the sample based on the table shown here. So next is the result and discussion for the scanning electron microscope. So for figure 6 and also figure 7, it was found that the presence of calcium silica hydrates and quartz are both found in the sample. So which means that when you have calcite and vitrite in your scan image, so it's confirmed that the carbonation occurred in the sample. Same goes here for the core sample at level 4. So this is core sample at level, core sample level 1 at level 2, and this is core sample 2 at level 4. So now we have the spot sample or the unsound sample 3 at level 2. Also was found that there is a presence of calcium silicate hydride and quartz, which are indication that the spot sample or the unsound sample is also carbonated. Okay, so here the summary, I can see that the summary of the SAM result is that for unsound concrete sample 3 and sample 4, they are all carbonated, these two samples. While for the core sample or the coring sample or the sound concrete, which is sample 1 and sample 2, are partially carbonated due to the less calcium carbonate crystalline existence. Next, so next will be the XRD diffraction analysis. So here we have the XRD discussion. Figure 10 shows you that the silica oxide is 44.5%. And from here, XRD analysis indicate that the predominance of silica oxide and calcium carbonate is identified. So this is for laboratory testing, objective number 2, and this is for core sample at level 2. So again, here is also another sample, core sample at 2 at level 4. The value of silica oxide is 67%. And here the sample for spot sample 3 at level 2. So the silica oxide reduced to 50.8. And same goes for this concrete spot sample 4 at level 4. So from all these graphs shows that the similarity of XRD patterns indicates that the same crystalline structure in the highest peak, which contains silica oxide and vitrite calcite, even though it's located on the different part of the building. So a peak calcium carbonate CO2 exists and no peak of calcium hydroxide or pollandite indicates that the spore sample are fully carbonated. A lower peak of calcium hydroxide or pollandite and the existence of a calcium carbonate, calcium carbonates indicates that the core sample are partially carbonated. So one indicates full carbonation and the other one indicates partly carbonated. So I'm going to go a bit quicker. So the FTIR is based on the wavelength. So here are the graphs that been shown in the sample test that been brought in the lab. So for concrete core 1, these are the spectrums result. And for core sample 2 at level 4, these are the spectrum result. For spot sample at 3 at level 2, this is the spectrum result. Same goes for concrete sample 4 at level 4. So what it means here is that from this test, it gives an indication that the presence of carbon monoxide in the concrete sample as basis for determining the presence of calcium carbonate. Next, we go for the TGA lab test, and this is based on the temperature. So these are all the temperature that we show you the what are the bonds between the chemical bonds in the materials that we brought into the lab. So here are the tests for sample 1 at level 2, test for sample 2 at level 4, and same goes for sample 3 at level 2 and sample 4 at level 4. So what it means here is that from all these four figures, you can conclude that the cement-based hydrate in silicon silicate and calcium hydroxide are fully transformed into carbonate instead of water due to the carbonation. So next, we will go to the summary. So these are all the lab test summary and what are the results that produced. And this is to sort of like give you all the broad picture of all the tests that's being done in the lab. Okay. So the best, so the summary of this is that the best effective methods for the NDT is the XRD method, and the effective method for the chemical test is the pH method. So this is proven and being rectified or backed up with the data from the lab. So this is just another summary of the chemical and NDT test, and this fulfill objective number 3. So objective number 4, result of summary. We have rebound hammer, phenolphthalein indicator, resistivity test, and this is just to show the result that have been extracted from all these tests, and that the quality of the inadequate are mainly to the carbonation attack to the structure, and require quick repairs to prevent reinforcement from corrosion. Okay, result and analysis, validation. So we have here the FEM. So we already complete the NDT and the chemical test. Now for the FEM, we have all these results where we have the mesh sensitivity analysis was being done. We have selected 3 types of mesh, 5, 10, and 20. And as we do the analysis, we run the analysis, the accuracy was much higher on the smaller mesh, which is give 80.9% result similarity compared to the 20%, which is 65.1%. So by doing that, we found that and also if we select the smallest mesh size, that will take a lot of time and also very tedious to do. So therefore, the study adopts 10 mesh for the entire final element analysis. For the corroded beam, we have compared with the experiment data, and we found that there is a difference of 11.9% difference with the perfect beam, and also difference with the corroded beam of 2.72%. So other than that, we can also see the corroded beam fail in compression due to the concrete strength reduction at cover area. And this is the case study beam that we use. The size of the beam is 220, and then 220 times 500 with 3 meter span. Reinforcement top was 210, bottom 220. The stirrups of 8 mm and spacing of 150. And we also include in the FE analysis the crack width for B1 beam is 8 mm with a length of 650 meter mm. And for the B2, the crack width is about 7.75 mm. So what I can conclude now is that based on that, we do a much more analysis. And so for the conclusion, conclusion number 1, BCA obtained for 11 number of defect. The average rating is, average score is 12.182. Average rating is C, fair. And action need to be taken is repair. And the visual assessment that the higher possibility carbonation attack from sign of falling, demolition, and corroded steel of reinforcement bar. Then the assessment based on non-destructive tests and chemical tests, partially carbonated for spore sample, fully carbonated for the core. Then for the effective method, we found that for the NDT is XRD, for the chemical test is for the pH. Then number 4 will be the integrity and stability of the structure based on NDT tests, chemical tests. We found that the high possibility of carbonate attacks of the signs of spoiling, demolition, and corroded steel. We found that the quality of the concrete is poor mainly to the carbonation process, highly unsafe, and require quick repairs. So for the conclusion, validate final element model, publish experiment, excellent agreement, experiment data, with previous study use surface-based cohesive behavior for bond modeling. Then number 6 is develop FE model. Analysis was successfully to evaluate the residual capacity of the case study beam, and relationship between corrosion degree and reduction capacity can be established. So thank you.
Thank you, Professor Engineer Dr. Raizal Saifunas bin Muhammad Rashid for the amazing presentation just now. Now we are open for Q&A session.
Okay, we have a few questions for Prof. Raizal. Okay, the first one, I read the first question first. Okay, The first one is coming from Fatmawati from Unimap. Okay, the question is, there is different phase or stages that need to be executed before conclusion can be made. For example, in the case of IPD Tampin, from the field assessment and lab testing stages to the residual capacity evaluation and modeling stage, what is the optimum completion time as desired by all involved parties without compromising the accuracy of your data? Okay. That's the first question.
Okay, thank you for the question, and very interesting question for me because there is a word mentioning about time. You know, how much time do I need to complete all this study? So, because as I mentioned earlier in my slide, that this work is basically just to identify the what are the best method for the NDT and also for the chemical test, and also at the same time for the residual capacity evaluation. What it means here is that if you are if you are doing a real project, this is, I can say, a very time-consuming task to complete, because you have a lot of sample that you need to take and a lot of lab testing that you need to do. But based on what I have just presented just now, by now, I think everyone who are listening to this presentation will know what are the best lab testing if you want to find anything that relate or just to justify whether that structure is being attacked with carbonation. So as I mentioned just now, for the chemical will be the pH test, and the ADT will be the XRD. Then with that, now with the model I've shown just now too, is also useful that where the model that we managed to come out can be used in any assessment that require this type of analysis, because my time was quite compact just now. The FE analysis will give you some idea on what are the percentage of capacity that is still there on the beam before it fails. You know, if I manage to sort of like tell you the thing is that beam, what we are being analyzed is that it still have its 50% capacity of the beam before it fails. So it seems something like that is whenever you present to a client or for it to be rectified, you have an idea on what are the strength of the existing beam before it fails and what are the methods for strengthening that you can use. So that is my answer for the question.
All right, Prof. Okay, I read the second question. Coming from same person, Fatmawati from Unimap. Okay, the question is, if sample need to be transported from site back to the lab for further analysis, appreciate if you can share how the sample storage was done during transportation, especially if the journey is a bit long, so that the actual sample condition on site can be preserved.
Okay, probably you missed that during my, probably the person that who asked the question missed out during my presentation just now. Or maybe I did not highlight that in the presentation. I cannot remember which one, because I was tasting the time to complete the presentation. The thing is that if you, for the core sample, you need to sort of like prepare a case where the core sample, you put it in that case that is will be undisturbed from the location, from the site to the lab. And while for the spall concrete, or the one that is where you take the specimen using drill, you need to put it in sort of like in container where probably a plastic container, which is airtight, and put it in a very sort of like not humid condition where you put in a case and bring it to the lab. I think that is a very valid question about how you make sure that the specimen from the site to the lab is being carried or being transferred. So as what I did is what I mentioned to you just now, to all of you.
Okay, Prof. Thank you for the Q&A session and sharing your expertise in this seminar. Thank you.
Next, let us continue the session with the fourth speaker for today's seminar. The speech will be delivered by Mr. Nur Azlan bin Abdullah from Public Works Department of Malaysia with the title of Sharing Experience of Forensic Investigation conducted by Structural and Concrete and Environmental Research Laboratory. Please welcome.
Thank you to Mr. Zakwan and Dr. Siti Nur Azila. Assalamualaikum and good afternoon to all distinguished guests, fellow presenters, and participants of this seminar. My name is Nur Azlan Abdullah. I'm a senior civil engineer for Public Works Department of Malaysia. Currently, I hold the position as a Deputy Technical Manager for Structure, Concrete and Environmental Research Laboratory at Centre of Excellence for Engineering and Technology, or which known as CREATE. I have been invited by the organizer at this seminar to share my experience in forensic investigations conducted by Structure, Concrete and Environmental Research Laboratory. So the topic of my presentation today is related to in situ testing of concrete structure. So this is the outline of my presentations. I have divided my presentation into a few subtopics. So I will start with introductions. This is where I will share information related to CREATE. And then I will go to concrete testing and assessment, where I will discuss the objective of testing and scope of concrete assessments. And I go further into in situ concrete testing in the third part, where I will discuss detail about the non-destructive testing and destructive testing that we can deliver in CREATE. And the fourth part is about the accreditations. And I will conclude my presentations at the end of this presentations. So introductions. So the history of CREATE, also called as Centre Excellence for Engineering and Technology, CREATE, began with the establishment of the JKR Training and Research Institute in 1998. Since that, various changes has been seen in the administrative structure and direction of the organization until decision was made to establish CREATE in 2012. CREATE was created to achieve the goal of producing a competent and professional staff to achieve JKR aspirations to become a world-class service provider and center of excellence in asset management, project management, and engineering services for the development of the nation infrastructure development through creative and innovative human capital infrastructure and technology. CREATE has started its operation at Alor Gajah, Melaka since 1st September 2016. So this is the vision and the mission of the CREATE. The vision of CREATE is to become a world-class center of excellence in engineering and technology, while the mission of CREATE, we have 5 missions. The first one is to develop competent human capital which is creative and innovative in the field of engineering and technology. The second one is to conduct research and development in the field of engineering and technology. The third is to implement testing program, certification and accreditation. Number 4 is to build a culture of innovation and creativity. And the last one is to spur sustainability in the management of infrastructure development. So CREATE is divided into 4 divisions, headed by a senior director, Engineer Razia Wahab, and assisted by 4 directors which lead each division. The divisions are Engineering Competency, Certification and Accreditation Divisions, Innovation, Engineering, Research and Development Divisions, Corporate Management Division, and also Asset and Facility Management Divisions. So this is the organization chart for Innovation, Engineering and Research and Development Division, where my laboratory, a Structure, Concrete and Environmental Research Laboratory, is become one of the units under these divisions. Innovation, Engineering, Research and Development Division consists of 9 units under the supervision of Engineer Dr. Shaliza Zaini Surya, which is Structure, Concrete and Environmental Research Laboratory, Road Research Laboratory, Geotechnical Research Laboratory, Electrical Research Laboratory, Mechanical Research Laboratory, Engineering Innovation Units, Research and Technical Management Section, Quantity Surveying Research Laboratory, and also Architecture Research Laboratory. The Innovation, Engineering, Research and Development Division core business are research, innovation and testing services. The operation of the testing laboratory is headed by a technical manager who is responsible for the overall technical operations for the laboratory, including the provision of the resource needed to ensure the required quality of laboratory operation. So we come to the slide where I will show the tests that have been offered by our lab, Structure, Concrete and Environmental Research Laboratory. For aggregate, we have a sieve analysis test. For concrete, we offer services related to slump tests, compacting factor test, concrete density, compressive strength test, porosity and adsorption, and sorptivity. And for steel reinforcement, we offer service related to tensile tests and bending tests. So next is the list of testing related to non-destructive testing and also the destructive testing. For NDT, we got electromagnetic cover meter, rebound hammer, ultrasonic pulse velocity, carbonations, half cell potential, and half cell potentials. And for destructive testing, or called DT, we got a concrete core. So I will go to the second part of my presentation, where I will share some information related to concrete testing and assessment. So categories of concrete testings. Basically, there are 3 categories of concrete testing, which is control testing, compliant testing, and secondary testing. The control testing is normally carried out by the contractor or concrete producer to indicate adjustment necessary to ensure an acceptable supplied material. Meanwhile, the compliant testing is performed by or for the engineer according to an agreed plan to check compliance with the specifications. The secondary testing may be required in situations where there is doubt about the reliability of control and compliant result, or to assess cost and damage of material duration of structure damage. So the in situ tests are categorized as secondary testing, where testing are carried out on in situ concrete or sample extracted from the structure, which may necessary to check compliance with specification and assessment of in situ quality and integrity. So next is the objective of in situ testings. The need for in situ testing may arise from a variety of causes, which include assessment of structural integrity and or safety following material deterioration or structure damage, such as caused by fire, blast, fatigue, or overload. Serviceability or adequacy of structural member known or suspected to contain material which does not meet specification or with design fault. The next objective is for assessment of cause and extent of deterioration as a preliminary to the design, repair, or remedial work. And the next one is for assessment of the quality of integrity or integrity of applied repair. Another objective of in situ testing is to monitoring of strength development in relation to formwork stripping, curing, pre-stressing, or load monitoring, or load applications. And the last one is to monitoring long-term changes in material properties and structural performance. So the scope of the assessments. The scope of assessment for in situ testing is divided into 3. The first one is for durability assessment, which concentrate upon identifying cause and extent of observed or suspected deterioration during reinforcement corrosions. The second one is strength assessment, which involves assessment of concrete strength. And the last one, the third one, is integrity assessment, which is carried out for determination of localized integrity or generalized assessment of behavior of whole structure. So testing method are divided. The test method are divided into non-destructive tests, or we call it NDT, and disruptive test, DT. The non-disruptive test is generally defined as tests that not impairing the intended performance of the element or member under test. All NDT methods can be performed directly on the in situ concrete without removal of samples. However, NDT could cause localized surface zone damage, and some of the tests are commonly described as partially destructive. Meanwhile, disruptive tests, or DT, is known as tests that require sample taken from the concrete, which may be used for laboratory tests. Sample taken from the concrete may be used for strength and other physical tests, as well as visual, petrographic, and chemical analysis. So this is the list of testing that categorized under durability assessment. So the desired property that we want to investigate is the concrete quality, durability, and deterioration. So the tests that have been included in this in the scope is surface hardness, ultrasonic pulse velocity (UPV), relative humidity, permeability, absorption, petrographic, sulfate content, expansions, air content, and abrasion resistance. Test method can be the testing equipment range from simple inexpensive handheld device to complex, expensive, high specialized item, possibly requiring extensive preparation or safety precautions, which will be used only when no simple alternative exists. So for corrosion, corrosion of steel reinforcement is related to the loss of passivity of the concrete as a result of carbonation of chlorides. So simple initial tests, involve localized measurement of reinforcement cover, carbonation depth, and chloride concentrations. The assessment may be followed by a more complex half-cell potential and resistivity testing to provide a more comprehensive survey of large area. So next is the type of testing method that we use to study the concrete strength. So in the list, we can see this. The first one is the core test, because the core test provide the most reliable in situ strength assessment, but also cause the most damage and are slow and expensive. So the another testing such as pull out, pull off, break off, internal fracture, penetration resistance, maturity, temperature match curing is considered as some of the partially destructive method that require less detailed calibration for strength but cause some surface damage, test only the surface zone, and may suffer from high variability. So next, I'll go to the type of testing method for integrity and performance. So the tests are tapping, pulse echo, dynamic response, acoustic emissions, thermography, radar, reinforcement location, strain or crack measurement, and load test. So these figures, okay, let me go. Okay. So these figures illustrate the stage typically involved in the implementation of in situ testing for investigation and assessment of concrete structure. So from the figure, we can see there are 3 stages involved, where the stage 1 is the planning stage, stage 2 is the non-destructive test, and the stage number 3 is for further testing. So in the starting of the stage, in the starting of the planning stage, we start with the established aim and information required, then followed by documentation survey, and after that we do the preliminary site visit. Preliminary site visit is necessary for gathering information related to accessibility and handling of the test equipment. The information gathered during the site visit could be used to ensure the safety of site personnel and the public during testing operations. So after we're done with the preliminary site visit, we need to agree in interpretation criteria, and then followed by a systematic visual inspections, initial test selection, and costings. The selection will be based on a combination of factors such as access, damage, cost, speed, and reliability. So we're done with the planning stage. So the second stage is the non-destructive test, where we do the test. The first one is comparative survey or comparative testing. Comparative testing is the most reliable application of a number of methods for which calibration to give absolute values of a well-defined physical parameter is not easy. So the most widely used method for comparative survey are surface hardness, ultrasonic pulse velocity, and surface tapping. So in the third stage for further testing, if we required further information related to the concrete, so it's suggested to do a localized investigation which include destructive tests such as core and also partially destructive tests such as a breakout. So if a result from the DT required more complicated tests, so we are proposing for a load testing. So whatever the input or the output that we get for the stage 1, stage 2, stage 3 will be using for the analyzing, interpretations and reportings. So from there we can draft the conclusions and decide the further action that we can do to the concrete. So the next part is in situ concrete testings. Okay. So next, I will briefly explain the non-destructive test and destructive test method that can be carried out by CREATE Laboratory in durability and strength assessment of concrete structure. So my presentation will focus on the non-destructive method, which consists of electromagnetic cover meter, rebound hammer, ultrasonic pulse velocity, and carbonation, while the destructive test method will involve only concrete core. So this the equipment for electromagnetic cover meter. So this is the equipment that we use, Prosec Profoscope. The electromagnetic cover meter is used to determine the location of the reinforcement bar and concrete cover, and can also be used to assess the reinforcement bar. So from what you can see, the equipment is compact, light and robust, and is designed for single-handed operations. So what we got is a Prosec Profoscope with a measurement range up to 150 millimeter maximums, with the capacity to detect bar diameter from 5 to 50 millimeter. It's quite light, weight is about 330 grams, and the standard test method for electromagnetic cover meter is BS1881 2004, BS1881 204 1988. So what is the principle of the electromagnetic cover meter? The basic principle is that the presence of steel affects the field of an electromagnet. So the presence of reinforcement within the range of the instrument is shown by the indicator. But somehow we need to make sure the regular check on the cover meter should be carried out to establish the accuracy of the instruments. So the application of electromagnetic cover meter. Electromagnetic cover meter can be used for, the first one is the quality control to ensure correct location and cover of reinforcing bar. Number one is to investigation of concrete members which record are not available. And the last one is to find the location of reinforcement as a preliminary to some other form of testing in which reinforcement should be avoided, especially for extraction of core, ultrasonic pulse velocity measurement, or near to surface methods. So this is the photograph showing our team members doing the cover meter survey. So on the left side, we can see the cover meter have been done on the beams. So this require quite longer time, because we need to detect one by one the rebar locations before we can do the coring on that beam. So the right one is pictures of our team members also doing the cover meter survey for a slab. This also is a preparation for coring. We need to detect the rebar before we do the coring. So, however, site calibration check should also be performed with the rebar and concrete tub involved in the investigations. This may involve the drilling of test holes at a range of cover values to verify meter readings, and if necessary to reset the equipment or develop a separate calibration chip. This is to confirm. This is basically we do once to confirm the exact location and the exact size of the bar. So the next job is just to detect the reinforcement. So we increase the accuracy of the reading of the cover meter. So I move next to the rebound hammer. This is the type of rebound hammer that we use, control concrete test hammer. The equipment consists of concrete test hammer and a grinding stone. The concrete test hammer is used to evaluate the surface hardness of hardened concrete, while the grinding stone is used to prepare the test surface by removing the grout or plaster that cover the concrete surface. So the impact energy of this hammer is 2.207 Newton meter, with a management range of from 10 to 70 Newton per millimeter square, its weight is about 1.5 kilogram. The standard test method for rebound hammer is MSEN 12504 Part 2, 2013. Concrete element to be tested with a rebound hammer shall be at least 100 mm thick and fixed within the structure. The area of the test location is approximately 300 mm times 300 mm. But we need, for areas exhibiting honeycomb scaling, rough texture or highly porosity should be avoided. So next is principle of the rebound hammer. The rebound of an elastic mass depends on the hardness of surface upon which it impinges. The test provides information about the surface layer of the concrete, which is not more than 30 mm deep, and the result gives a measure of the relative hardness of the zones. The concrete hammer needs to be calibrated periodically using a calibration anvil to ensure the concrete hammer is properly functions. So this is the picture showing the rebound hammer test. So the rebound hammer is very simple to use and may be operated either horizontally or vertically, either upward or downwards. The surface of the concrete must be smooth, clean and dry, and should preferably be formed. According to MSEN 12504 Part 2, it recommends that not less than 9 readings taken over an area not exceeding 300 mm square, with the impact point no less than 25 mm from each other or from an edge. If you can see in the right pictures, they are grid. We are using the grid because the grid can be used to reduce the operator bias. And from the rebound hammer test, the scale reading is known as the rebound number. So the application. The rebound number can be used to assess the uniformity of in situ concrete, delineate zone or areas of poor quality or deteriorate concrete in structure, and provide an estimate of in situ composite strength with suitable correlations. Surface hardness measurement give more consistently reproducible result than any other method of testing, and the use of the rebound hammer for strength estimation of in situ concrete must never be attempted unless specific calibration charts are available. So next is how we interpret the result from rebound hammer. So the rebound number of the test location shall be taken as the median of all readings. So from the table we can see the rebound hammer number above 40 give an indication that the quality of the concrete is in excellent conditions. But somehow, if the rebound hammer number is below 20, it shows a poor or delaminated quality of the concrete. The rebound hammer is furnished with correlation curve developed by the manufacturer using standard cube specimen. However, the use of this curve is not recommended because material and testing conditions may not be similar to those in effect when the calibration of the instrument was performed. So most of the time, we only reported the rebound hammer number. We not do the correlation with the strength based on the explanation that I given before. So ultrasonic pulse velocity. The equipment we got is a ProSec Pandic lab. It consists of a display unit, a transducer, a pair of transducer, BNC cables, coupler, calibration rod, and battery charger. The UPV can be used for pulse velocity measurement, path length measurement, surface velocity measurement, and crack depth measurements. So for the equipment that we have, resolution is 0.1 microsecond with a transit time range from 0.1 to 9,999 microseconds. The transducer frequency is 54 kilohertz with a weight of 1.3 kilogram. So the standard test method for this test is MSEN 12504 Part 4, 2013. The minimum path length required is 100 mm for maximum aggregate size less than 20 mm and 150 mm for maximum aggregate size from 20 to 40 mm. The principle of this test, UPV equipment measure the transit time of a pulse between transducer placed on the surface of a concrete. The pulse velocity can then be calculated using the measured path length through the concrete. We can use this equation where the pulse velocity equal to the path length divided by the transit time. It's very important to ensure that adequate acoustic coupling using the coupler of the transducer to the surface under test by applying a thin layer of couplant to the transducer and the test surface. In some cases, it may be necessary to prepare the surface by smoothing it, and the equipment should be zeroed using the calibration rod on a regular basis to ensure we got the correct and we got the better accuracy. So this is the picture shows the transducer arrangement, which we have a direct method on the upper left side, so followed by the semi-direct method at above, and also the indirect method on the side. So the direct method is the most reliable approach, since the maximum pulse energy is transmitted at right angle to the face of transmitter, and the path is clearly defined and can be measured accurately. The semi-direct method can sometimes be used satisfactorily if the angle between the transducer is not too great and if the path length is not too large. The semi-direct method is used when the direct arrangement cannot be used. For example, at the corner of the structure. This one shows it will be done on a column at the corners of the structures. So the indirect method, the third method, the indirect method is definitely the least satisfactorily, since the received signal amplitude may be less than 3% of that for a comparable direct transmission. The indirect method is used when only face of the concrete is accessible, or when the quality of the surface concrete is relative to the overall quality is of interest. So from the figure we can see most of the time we do indirect method. We use the indirect method transducer arrangement for slab assessment. So the application of UPV, the measurement of pulse velocity can be used for determination of the uniformity of concrete, the presence of crack or void, changes in properties with time, and in the determination of dynamic physical properties. So the measurement may also be used to estimate the strength of in situ concrete elements or specimen with suitable correlations. So how we interpret the result? So from this table, we can see that the pulse velocity more than 4.5 kilometers per second shows that the concrete is in a very good to excellent conditions, whereby pulse velocity from 3.5 to 4.5 kilometers per second shows that the concrete is in a good to very good, but the porosity slightly may exist in the concrete, and the result from 3 to 3.5 kilometers per second shows the concrete is satisfactory, where we expect loss of integrity is expected. And for a concrete that have a pulse velocity less than 3 kilometers per second, we categorize it as a poor, where we suspect a loss of integrity exists. So next is the carbonations. Okay, the test is used to measure the depth of carbonated layer near the surface of hardened concrete. Determination of carbonation depth is in hardened concrete by Fensterlin's method is based on the BSEN 14630/2006. The test may be used on site or in the laboratory on test specimen, core or fragment removed from hardened concrete structure. The carbonation is indicated by the changes of the color of concrete, where the depth of concrete onto which the concrete remain colorless after the Fensterlin solution reverse spray shall be measured as the depth of carbonation. So from the figure we can see we measure the depth of carbonations, where the according to the core sample we can see this part of concrete was not changed the color, it remained colorless. So this is the area that we suspected have been affected by carbonations. So we move to the destructive concrete, the destructive test, which is a concrete core. This is the equipment we have for the time being, a Shibuya core drilling machine. Its rated input is 1,500 kilowatts. Okay, the gear speed is first speed. Travel length is 548 millimeter. The rated load speed is 610 RPM, where it can support a core bit diameter from 60 to 160 millimeter. It's quite heavy, about 13 kilogram, and we use a standard test method MSEN 12504 Part 1 2013. So a core is usually cut by means of rotary cutting tools with diamond bit, like what we have. This equipment that we got is this concrete drilling machine consists of a simple single speed motor and fixed stand column with a specification, as I mentioned before. So the equipment is portable, but it must be firmly supported and braced against the concrete to prevent relative movement, which will result in the distorted or broken core. Water supply is also necessary to lubricate the cutter during the coring work. So the principle of concrete core. Core extracted using a core drill are carefully examined, prepared by grinding or capping, and test in compression using standard procedures. The aggregate size has a significant influence on the measured strength. Thus, the ratio of diameter to the maximum aggregate size shall not be less than 3. So the ratio of diameter to the maximum shall not be less than 3. So the length of core whereby is to be taken for strength testing depend on the diameter of the core, the possible method of adjustment, and whether comparison is to be made with cube strength or cylinder strength. So the preferred length to diameter ratio are 2.0 if the strength result is to be compared to cylinder strength, or 1.0 if the strength result is to be compared to cube strength. As for Malaysia, most of the time, we are comparing the result with the cube. So the preferred length over diameter ratio that we use is about 1.0. So application, the application of concrete core. Core tests provide the most reliable in situ strength assessment and can be used to assess the degree and extent of concrete deterioration due to load or environmental causes. Core are also frequently used as sample for physical, in case for water absorption, crack depth, void, and also aggregate distribution, and for chemical analysis, especially for carbonation depth and petrographic. So this is the pictures. Our members doing the coring work. The left side, on the left side, coring work at the beam, and the right side is picture for the coring work done on a slab. Concrete core should be taken at point away from joint or edges of the concrete element and where there is less or no reinforcement. That's why before we do the test, before we start with the coring work, we need to detect the reinforcement first using the cover meter survey or using the electromatic cover meter. Testing at around mid-height is recommended for beam, column and wall, and surface zone tests on slab must be restricted to soffit. Care must similarly be taken to discard material from the top 20% or at least 50 mm of slab when testing cores. It is important to drill the core perpendicular to the surface of the concrete and keep in rigidly position during coring to prevent relative movement which will damage the core. So this is a sample of core that we caught from slab. So each core must be clearly labeled for identification immediately after drilling, where the core location and orientation within the element from which it has been drilled should be properly recorded. And also the photograph of core are also valuable for future reference, especially as confirmations of feature noted during visual inspections. This is a process of trimming and capping of core samples taken during the coring work. Each core must be trimmed and the end ground or capped before visual examinations, assessment of excess voidage, and density determinations. Trimming should give a core of a suitable length with parallel end, which are normal to the axis of the core, whereby core should be ground or capped with a high alumina cement mortar or sulfur mixture to provide parallel and surface normal to the axis of the core. So the cap that we use should be kept as thin as possible and shall not be greater than 5 mm thick. So this is the comprehensive strength test for the core samples. So core samples, in order to determine the strength of the concrete, core samples are loaded to failure in a compression machine. The maximum load sustained by the sample is recorded, and the compressive strength of the concrete core is calculated based on the formula shown in the slide, where the compressive strength is equal to the maximum load divided by the cross-sectional area, and the rate of loading is within the range of 0.6 plus minus 0.2 Newton per millimeter seconds. So I end the presentation with the topic of in situ testings. So I want to share some things about the accreditation for CREATE. So I would like to inform that CREATE laboratories have been accredited by Department of Standard Measure with MS ISO IEC 17025 certifications. Currently, 16 types of tests have been accredited for CREATE laboratories, where 3 of the tests are carried out by our lab, Structure, Concrete Environmental Research Laboratory. So the test, as mentioned in the certification, is the compressive strength of concrete cube or cylinder. The test number 2 is the compressive strength of concrete core, which is very related to what I ever said before. And the third one is for tensile test of metallic material. These accreditations show that a CREATE laboratory operate competently and generate valid results, thereby promoting confidence in our work. So just go for the conclusions. All the test methods which are available for in situ concrete assessment have limitations related to issues of repeatability, accuracy level, and access requirements. So combining method may help to overcome some of these difficulties, but advanced technology may offer better solution to deal with the challenges in the assessment works. So with that, I end up my presentation today. I hope the information shared during the presentation will give better understanding to all the participants about the role of CREATE in forensic investigation, especially related to structure and concrete laboratory. Okay, for that, I say to thank you for your attention and please stay safe. Thank you.
Thank you, Mr. Nur Azlan bin Abdullah, for the amazing speech just now. Now we are open for Q&A session.
Okay, we have 2 questions for Mr. Azlan. Okay, the first one is your slide shows that the CREATE laboratory has been accredited. My question is, does CREATE have a procedure that need to be followed by the contractor if they want to test their sample at CREATE lab? And what is the price offered?
Okay, thank you for the questions. So just like I mentioned, that CREATE have got the certification for certain type of tests. So right now we are allowed, if the contractor to send their specimen or their sample to us for testings. So there are a few process. So they can contact our laboratories staff or me to arrange for any appointment related to that. So yes, we got a price for whatever test that we do. So it's quite competitive. The price is quite competitive compared to other laboratory, but I don't show the price here. So I welcoming the contractor or whoever's out there who wants to send the samples for testing. You can just contact me or my staff to get better information about that.
Okay, so for the second one, does CREATE provide forensic work to the public, or it is just only for the government project?
Okay, this is quite a critical situation where we actually focus the investigation works for government project. But somehow there are certain situations where also the job have been requested for our job outside the CREATE. Based on experience, I've done one job, but that one is only for customer service for CSR only. So I will quite mention that these investigations services is mostly for government project.
Thank you, Mr. Nur Azlan, for the Q&A session.
Okay. Thank you.
The floor would like to thank again for your presentation. Thank you.
All right, dear ladies and gentlemen, we will go for lunch break. Please note that after the lunch break at 2:15 p.m., we will continue our seminar with the 5th presentation by Dr. William Chiang Wai Lim from Sekian Bentley Systems, Singapore.
Okay. Ladies and gentlemen, the next session is going to start in 5 minutes. Thank you. Ini Zakwan seorang je masuk.
Distinguished guests, ladies and gentlemen, we are going to continue our session with the fifth speaker, Dr. William Chiang Wylam from Sequan Bentley Systems, Singapore. Without further much ado, please welcome Dr. William Chiang Wylam from Sequan Bentley.
Two, one, live now.
All right. Good afternoon, everybody. My name is William, and thank you for the introduction. I'm talking to you live from Singapore today. Due to the COVID restrictions, I just couldn't travel back to Malaysia to present this case. So I hope you're hearing me loud and clear. If it's not, someone please give me a comment that you can't hear me. Am I good to go? All right, I assume it is okay. All right, good afternoon, distinguished guests, esteemed colleagues, ladies and gentlemen. The title of my lecture today, From Ground to Cloud, Computational Geotechnics and Forensic Engineering. It touches on the use of geotechnical modeling analysis for the purpose of identifying mechanisms. The ideas and lessons learned from the cases that I'll be presenting can be applied directly to forensic geotechnical engineering. So let me begin by giving you an outline of my presentation and lecture. The outline itself concerning this seminar is on the forensic geotechnical engineering. Forensic geotechnical engineering is about analyzing the causes of failure, understanding what went wrong, why, and when from the geotechnical point of view, these things need to be sort of considered and analyzed. The role of a geotechnical or forensic geotechnical engineer is often complex and needs to be completely comprehensive to satisfy the technical and legal perspectives. Often, the geotechnical engineer is required either as a technical expert to understand the failure or as an expert witness in the court of law. Geotechnical engineers working with forensic evaluations must apply science and engineering know-how within the rules and practice of the legal system in order to be effective in presenting the reality and resolving the conflicts. Such rules and practice will vary from country to country. The technical forensic investigation requires the collection of data, problem characterization, development of failure hypothesis, a realistic back analysis, observations of in situ situation, and in some cases, the performance monitoring is also important. In this presentation, the next 15 minutes, I will share my or our experience or lessons learned from some of the case histories. Not all the case histories are entirely of forensic or collapse in nature, but there are essence in there that can demonstrate the viability and the importance of preparing and knowing what to do with the geotechnical modeling. The outline itself, there are three parts. I'll first talk a bit about the geotechnical forensic engineering, which I've done a bit, and I will convey a message using the geotechnical, well-known geotechnical triangle, and also what is computational geotechnics. And part three, this is the gut of the presentation. I will showcase 4 case histories, and each of these case histories has some very important lessons to be learned. And I'll summarize these case histories as something you can just take home and think about it. And part 3 will be a short introduction to some of the emerging technologies and what the future holds. And I'll conclude my presentation by then. So introductions. And when we look at geotechnical analysis, there are always 2 things that we need to satisfy. When I look at the title of my presentation, it's From Ground to Cloud, meaning is that before we can even look at what is happening with the top structure, we must know what's actually beneath the structure. And from ground to cloud also means that in this day and age, moving towards the construction or industrial revolution 4.0 or geotechnical 4.0, we need to embrace technology. for example, digital twins. You see some of these ideas of digital twin coming into play later. So there are two things we always need to satisfy in any geotechnical modeling analysis. The first thing is the ultimate limit state, which deals with instability. The first thing we want to do is that when we construct or design any structures, that it doesn't fail. So instability calculations and modeling are very important. And number two, serviceability. A structure can deem to have failed, not entirely of a collapse in nature, when the deformation itself exceeds certain engineering tolerances. So there are these two main things we always need to address, model, and analyze to see what's going on. Geotechnics is a very interesting and difficult subject and is regarded by many engineers as a kind of black art. Difficult as soil is as an engineering material, the problems confronted by engineer in tackling a ground engineering problem is more subtle. The struggles of Terzaghi in establishing geotechnical engineering as a valid engineering discipline are well documented in references. More than half a century ago, or later, the practice of geotechnical engineering has grown leaps and bounds, and the era of computation, relying on classical and modern soil mechanics theorems, is the current status quo. Forensic geotechnical engineering is the investigation of geotechnical materials and structures that fail or do not perform as intended. The last statement is very important. The consequences of a failure or instability can be catastrophic, causing the loss of property and even the loss of human lives. Generally, the focus of geotechnical forensic engineering analysis is to identify the cause of failure, the causes of failures, or to improve the performance of a structure to assist in determining the facts of the geotechnical failure. So let me give you some example what a geotechnical model looks like when you conduct, let's say, a finite element analysis. And from where I work with, from the computer simulation group, we use Plexis a lot in 2D and 3D. So this is an example of what a computer analysis looks like for a deep excavation and a slope or even embankment in the 2D. Now, in this current day and age of climate change, the reinforcements of dikes are even more important, which you see in the central column of the slide. And the next one will show you some ideas of a 3D analysis in all its glory. You look at a deep excavation on the top left, and you look at a tank, you look at foundation, and even using computer geotechnics to look at heritage sort of structures. And you can see on the far right-hand side is the well-known Bayon Temple in Angkor Wat. Now, what is geotechnical finite element analysis? Geotechnical finite analysis is part of the group of numerical analysis. You have heard of finite difference, you have heard of boundary element methods, you have heard of discrete element methods. And what I'm going to present today, which is well applied in the industry, is the finite element approach. And in the coming future, perhaps the measure techniques will also be very relevant and important, dealing with a sort of large strain and large movements, especially the material point method, which is now getting very popular. Now, the next couple of slides, it's more for completeness. This is when I teach a course, or when my professors and I will teach a course. This is where we begin by teaching the geotechnical methods of numerical analysis. I will leave this slide here so that when you read the PDF, which I'm going to attach to my presentation, so that you get an introduction to what is FEM for those of you who are new to this method. But just to mention, the FEM method has been used in many fields of engineering of practice for the over 40 years. And when properly used, this method can produce realistic results, which I'm going to demonstrate and showcase in the next 4 case histories. A good analysis which simulates real behavior allows the engineer to understand the problems better. And even more so when you're dealing with forensic geotechnical engineering, which is to look back at what could be the cause and the mechanism. The geotechnical finite element model allows us to see all these scenarios. Of course, there are the advantages and disadvantages and some unavoidable uncertainties. And the areas whereby we are not variable, we need to spend more time to sort of ascertain these sort of things. For example, you look at the part C mentioned here, nearly unavoidable uncertainties, things like ground profile, initial conditions, which is connected to the genesis of the ground, boundary conditions, the appropriate model for the modeling, and some of the model parameters. I will also talk about the suitability of using 2D and 3D in forensic analysis here. Most of the time, forensic analysis is also talking about back analysis in connection to perhaps to technically monitored data. I would like to use this well-known geotechnical triangle because it basically integrates all the aspects that are needed to build up an understanding of your forensic geotechnical modeling. The ground can be highly variable in nature, we all know that, but we came into the view that the main problem confronting the engine is not so much of the complex nature of the soil as a material, but lack of appreciation of the number of aspects that must be considered in tackling ground engineering and geotechnical problems. Relying on a single aspect, for example, empirical procedures or computer modeling itself, can also lead to failure. You cannot just use one. You need to have all these things in your tool set to be able to understand what's going on when you do the back analysis. In this presentation, I will highlight some key aspects needed to ensure good application of computer geotechnics in forensic engineering. Depicted within this slide is the well-known geotechnical triangle of Berlin. And in this slide, you can see four very distinctive aspects. The one is ground profile. Aspect number two, which is on the lower left, is measuring and monitoring. And aspect 3 is the appropriate models on models. And aspect 4 is experience and empirism. So let me touch a bit on the aspect 1. Number 1 is concerning establishing the ground profile, which is a key outcome of the ground investigation. The ground profile is a description of the successive strata in simple engineering terms together with the groundwater conditions and the variations of these strata across the site. Also, it is vital to understand the geological processes and man-made activities that form the ground profile, hence the genesis of it and the stress history. Aspect number 2 is concerned with the measured behavior. The activity associated with this aspect involves making measurements of the mechanical behavior and interpreting the measurements. It includes laboratory, field testing, and carrying out field observations of the ground and structural movements and measurements of groundwater pressure and flow. Rigorous methodologies and advanced instrumentation are often required for this work. The measurements require interpretation, which needs an appropriate analytical framework. A good basic understanding of the mechanical behaviors of the soil and rock is essential to these activities. So in a nutshell, for aspect number 2, it's about characterizing the behavior of the ground and also the structure. So the material modeling is very important. Now, aspect number 3 is concerning building up the technical model. So this is what in the triangle, it says the appropriate model, because this is concerned with the modeling process to identify the mechanisms, whether it is a stability problem, a deformation problem, or the both, then the model should take care of it. And it is also in aspect 3, when we example the model, how do you idealize the problem? The modeling process is not complete until the responses has been validated and assessed, and we'll show you some of these issues in some of these cases. And the modeling itself may involve a number of iterations. A model can be a simple conceptual one, it can be a physical one, or it can be anything that is of complex in nature, like a sophisticated numerical model. Now, aspect number 4 is very important. It is about empirism and experience, right? I mean, you need experience to be able to interpret and also to find out whether the models you have built, and it is also experience that ties up aspect 1, aspect 2, and aspect 3. So let me go to the case histories now. This is part 2. There are 4 case histories here, and each of these cases, mark here 1, 2, 3, 4, and each of these is also connected to the 4 aspects that I have presented. The first one is about visualization and modeling. The second one is about how do we create the model? Should we use a 2D or 3D? And the case 3 is about influence of material modeling. And you shall see that in case 3, if you do not select the correct material response, you're not going to get the correct mechanism and failure mechanism. And number 4, basically number 4 here encloses all the 4 aspects. You need the 4 aspects to be able to solve the problem in case 4. Now, this one was an award-winning project 2 years back from the Year in Infrastructure from Bentley Systems. And in this case history which I'm presenting, although the case history talks about the visualization, I think visualization is a very important thing when it comes to managing project. And in the event of a forensic type of study, going back to the visualization itself or the model itself to be able to visualize what happened prior to the collapse is a very important thing. So next few slides will give you an idea of what's going on. And the beauty of visualization is that it gives you this spatial awareness of the project site, the problem on hand. And this is concerning this old structure, the Admiralty Arch in London. And you shall see that this visualization itself tells us what is the nature of the project. It's concerning refurbishment, yes. And the next thing we need to do is to ensure that the refurbishment and the things we're going to construct will not cause any distress or failure, which will then push the project into kind of forensic phase. So if you look at this video, it shows you beneath this old heritage structure, you have a tunnel tube, and you also have the service utilities. And because of the refurbishment needed, we need to sort of underpin and build additional structure beneath the building. And the visual will show you the what is happening beneath the structure. Now, when you build a retaining system, these are some of the things you need to consider. You have a building on top, very sensitive to movements. You have earth pressures that you need to sort of design for to size up the excavation. And you also have, out of the response of excavating, the heave that might cause a distress to the, for example, in this case, the tunnel tube beneath it. And we need to design to ensure that the retaining system, the RSS, is stable, and the movements are too much to the point that it causes distress to the structures around it. So the challenge was to figure out or to ascertain what are the building movements and tunnel movements. And then once that is identified, to the help of the visual and the 3D model, we can then move towards using numerical tool to look at these sort of problems. So you have the model, then we push the model to analysis. And the same thing can be then applied into forensic work. Once you're able to visualize or sort of pick up how the actual construction work was done. So of course, the first thing they did was to use a 2D model just to check that it is necessary to do a 3D. And of course, in a later part, a 3D model was built. And to do, whether to use a 2D to 3D, to come to that conclusion, a part of the success is to go back a step before the analysis to see how the model basically evolves, the progression, the site sort of changes. And this was a 3D model that they have constructed, a very good one. And at the end of it, after the analysis, basically from a finite element analysis, at the end analysis, you get the output, the results, and the results itself will enrich the level of detail in this model here. In this current day age, talking about digital twin and BIM, basically the level of development will increase. And this will be very important to document the progression of the success of the project. An event of any conflict or possible forensic investigation, we can always go back to look at what happened and what actually went wrong. All right. Okay. Now, for my next case, the next case is concerning idealization, whether to do a 3D or 2D. And to talk about this case history is concerning the stability analysis of embankment age supported by a deep cement mix. And if you look at this, remember in the prior to a few slides, I talk about the importance of looking at stability. There are always two things that we need to satisfy. First, ensure that it doesn't collapse. And the second thing is to ensure the movements, deformation is within the engineering tolerances. Now, this is concerning stability, more so towards a large strain type of problem of analysis here. So let's look at a problem whereby an embankment or a reclamation field is on soft marine clays. The idea right now is to improve the soft ground so that the material on top, especially what you're looking here, the reclamation field, can be supported. It's a 10-meter height. Now, DCMs are discrete inclusions. Now, the question has always been in a lot of engineers' mind is that how should I model this? There are three models that we're going to present because one is a plane strained homogeneous model, one is a wall model, one is a true 3D model. Now, the characteristics of the model is that the DCMs and how much you improve it by 10%, 20%, 30%. AC is the column cross-sectional area. A is the total treatment area. So this AC divided by A will give you the area replacement ratio. So we're going to look at 10%, 20%, and 30%. This is one typical example why we need to run, first and foremost, a 3D and 2D to check. And many times, people prefer to run a 2D because 2D is quicker, it's less expensive. But to check whether the 2D analysis is the correct one, you need a 3D and perhaps even tie it with a monitored data. So the methodology is that, first of all, you have the model 1, model 2, and model 3. And in the model 1, it is basically a wall model. The model 1 is a composite, so everything is homogenized. And the model 2 is a composite wall. And the model 3 is a full proper 3D. So let's look at first the composite. So composite means that all the material behavior is lumped into the single one. This is very popular. And on this sheet, there's this equation here that sort of teaches you how to sort of comply to this homogeneous rule. And for the 2D composite block, we look at the three cases: 10% replacement, 20% replacement, 30% replacement. So what happens here is that basically the material behavior or the strength itself gets improved, but you don't really model the geometry. And you can see that, of course, the factor safety should increase because when you do more replacement, the strength goes up, and this is being properly captured. Now, let's look at plane strain. You look at plane strain right now, the wall model, instead of homogeneous, right now you have a wall structure. And same thing, you have 10% replacement, 20%, 30%. And again, of course, the factor safety increases as the cementation goes up. Now, let's look at 3D unit slice. Right now, there's no simplification of the DCMs, and DCMs are properly modeled as discrete inclusions. And this is no simplification of the model here. Again, the factor of safety for 10% replacement ratio, 20% and 30%. And you shall see that right now, if you compare all the factor of safety, right, 10%, 20%, 30%, the composite block model gives you a very high factor safety. And as you go down into the 30% and you look at the DCM, right, the factor safety is 2.2. So which one do you believe, right? Of course, we all know, based on experience, aspect number 4 in the geotechnical triangle is that the 3D basically is much better than the rest because right here, we have no assumption. So if you're looking at forensic work, I think 3D is the program to start off with. But of course, in these case, you can see that the column walls, the 2D wall model is actually not too bad. But we only know that it's not too bad once we have done the 3D and we have a little experience to sort of indicate the 2D model actually is, if the column wall is actually quite appropriate here. Now, let's look at case number 3. I need to rush a bit because I have only less than 25 minutes. Case number 3 is about selecting the correct material model representation. Now, this is concerning the aspect number 2 in the Berlin geotechnical triangle that I've presented. Mainly the main important thing is to select the correct material response, but that doesn't mean the aspect 1 and 3 and 4 is not involved. Especially 4 is also equally important. So let's look at what's the situation. In a lot of brittle material like cemented soils, using the mole coulomb itself is insufficient. I can't go into the depth of the formulation of the model. The model here is known as the concrete model or the SCM model previously. The concrete model is a kind of a damage plasticity model. It allows us to model the implicit nature of cracking, the brittleness, and also softening. All right. So the slide here is for those who are so inclined. You can look at it, and if you're keen, you can look further into it to figure out what's going on. But right here, I want to give you the gut and the message and the lessons learned from these case history. The importance of selecting the damage plasticity model, known in practice as the concrete model. Of course, before we can use it, we must ensure that the model can perform to what it should be, which is cracking, modeling cracking in its implicit sense. So we went back and dig up a few case histories. First is to look at the indirect tension in a notch beam and a notch beam in terms of mixed fracture. And this was then modeled in Plex 2D, plain straight, using the constitutive model. And you shall see that the model present actually after a few iterations, when they calibrated the parameters, it actually performed very well. You can see the propagation of the cracks and also the softening part. If you look at the chart on the far right hand side, you can see the experimental data of rods 1988. The numerical ones is indicated with the blue line, and the experiments are the scatter of the dots. So this is for the indirect tension in notch beam. Now the second one is the notch beam in mixed fracture mode. Again, after a few iterations, we were able to calibrate the model, and the model parameters now has been sort of effectively demonstrate the propagation of the cracks and also the softening. So once this is done with the appropriate material model selected, with the validation and verification, remember aspect number 2, which I presented just now. Now we look at a problem which was, this is a case history that was previously presented by Professor Harry Tan, my mentor. And I'm sharing his view because there are important lessons to be learned. And this is a real case history. It's about the collapse of a cement-treated soil column. You can see on the photographs here, you have occurrence of the initial vertical crack. And once it collapses, you can see that the collapse of the front row columns with its explicit horizontal cracks across them. And you can see the cemented treated soil column behave as brittle material. So you need to, first and foremost, select a constitutive model to be able to give you that correct material response, validate it and verify. So this was the model where we built in 3D. And it's a cell-like kind of in nature, which makes it even more interesting because you cannot do this with a 2D model. This is essentially a 3D problem. Now, I'm going to show you a comparison of the model once it's done with the concrete model, which is what it should be, and the one that is done with the mole coulomb without the a proper modeling of the tension strength. So I'm going to click the video and top and bottom. And I hope that you can see the movements. So the one at the bottom is a bit delayed, but what is interesting is that at the end of both of these videos, the concrete model has already been completed, the analysis. And if you look at the bottom, the top one, the concrete model predicts a cantilever type of a movement and collapse. Whereas if you look at the mole coulomb model, you have a bit sort of cup right at the edge of where it connects with the basement. And you shall see later that actually the concrete model at the top gives you the correct response. And what you should be looking at in terms of numerical analysis, because of the brittle nature, is the tension cutoff points seen here as the cutoff point. And of course, the failure point, you can see the ground sort of settling into the ground. Now, the next slide is about the movement. So let me show you the mole coulomb model first. This is the mole coulomb model looking at the screen. And you shall see the movements. You have heave rolling in. And as it reaches large deformation, you can see that a lot of displacements are concentrated at somewhere at the mid-height of the ERSS. And if you look at the top, which you already know after modeling is the correct response, you can see that how the wall basically moves forward in a sort of a rigid rotation towards the excavated zone. And this, if you compare it to the pictures that I saw, of course, when you look at the concrete model, as it sort of moves further, it sort of collapses towards the unretained site here. And hence, this case number 3 demonstrates that selecting the appropriate material response, in this case, a damage plasticity model called CM, is really important. And right now, if I were to show you some of the slides, just to wrap up case number 3, is that you can see the difference of the two models. The failure mechanism between the two models is vastly very different. You shall see that this is due to this. All right. So how do we know? Aspect number 2 and aspect number 4 is very important. Of course, aspect 1 and 2 and 3 is also very important in this case. Now, case seen here is case 5. It's actually case 4. I have to remove one case because due to shortened time. This is due to the tunneling impact of a pile and ground improvements. This is looking at a problem which is a semi kind of forensic work, because you have actually 2 tunnels, the eastbound and the westbound. And the first tunnel that went beneath actually caused excessive movements and was pretty dangerously very close to the limits of what's it being designed for. So the impact of tunneling adjacent structures is the case number 4. And of course, if the impacts are high, although the building you've seen on top on the orange photo there, although it's a crack can be deemed a failure because it actually surpasses the serviceability limit state. Of course, what you're seeing on the top right is something that you don't want to see, because a collapse is not something that is you want to reach. You see, we always design against collapse, and then we also need to look at the deformation. So this part here, the impact on surrounding soils, just to give you an idea what's going on, you build a tunnel, a single tunnel, and the impact on it on adjacent structures, right? There is this building impact assessment cycle, stage 1, stage 2, stage 3, and most of the time, and it reaches stage number 3, this is where the numerical techniques are needed. One, perhaps using empirical or sort of a closed form solutions, and it goes to stage number 2. And on the far right-hand side, you can see the level of distortion and impact on the structure based on the balance and also Buscardine curve. And what you see right in the middle of these presentation is giving an idea of the importance of monitoring the construction work. It is also because of the availability of the monitored data, the geotechnical engineer on site can do the analysis and build up an intervention scheme to ensure that the second tunnel doesn't cause a collapse or excessive deformation. So let me show you what's going on. Most of the time in the first set of analysis, we will use some sort of a Gaussian curve to make impact analysis. As you know, the Gaussian curve in a nutshell is restricted to a single tunnel, and this can't be applied to a double tunnel. And of course, all these settlements are caused by the volume losses. You've seen here on the slide on the far right-hand side, mechanism 1, 2, 3, 4, 5 will cause all these volume losses that will then cause movements around the construction. Hence, the buildings will be in distress. And what's happened here is that you have a lot of houses and buildings. And what you're seeing here, you have the settlement tunnel array, vertical side. This is where the tunnel eastbound and westbound are located. Now, this was a project done by a good friend of ours, by Professor Pungkasim from KMUD. I thank him for the sharing of this information. And I think this is a very good case to sort of showcase the importance of monitoring and having all these 4 aspects, 1, 2, 3, 4, in your arsenal of forensic work. Of course, this is not a collapse problem, but it's quite close to it, because you look at the westbound tunnel, which is right at the bottom. When this was constructed, this tunnel itself already caused so much movements that the buildings around it were very close to it was beyond the what was being catered for in terms of movements. And of course, everybody was worried because all the trigger values were reached. So with that, with the availability of even a simple ground settlement optical points right at the surface, the question right now is, because the westbound tunnel has caused so much distress, based on aspect number 4, experience, you will know that EB itself, the eastbound tunnel, when it comes in, and even closer to all the structures, right? The collapse and the excessive movements will be imminent. So it is through the use of FEM, we were able to figure out what to do, what sort of intervention. First and foremost, aspect number 1, the ground profile is very important. Knowing what's in the ground, especially more so in the Bangkok soils, the groundwater itself, it's if you look at it, there is sort of under pressure in a certain level because of due to the long years or many years of withdrawing water, and the groundwater itself has to be properly modeled to get the correct initial geotechnical stress history or soil stress history, and the genesis itself, how the soil stresses come to the point when the tunnel goes in. And number 2, selecting the appropriate model to allow us to capture the deformation. At least the Harning soil model or Harning soil model with small strain is very important. Capturing the small strain response is very important in this sense. And aspect number 3, getting the appropriate 3D model with the correct placements of the tunnels are very important. So all these aspects, 1, 2, 3, 4, 5, or 1, 2, 3, 4, with experience is needed to build up these very rich geotechnical model for so-called a forensic back analysis. So this was the model that we used to calibrate the westbound tunnel. And once it was calibrated, then we sort of said, okay, we are pretty confident that when we proceed with the numerical modeling of the eastbound tunnel here, we will see what will be the additional movements that will be added into the current ones. And I will leave you to read it in your own time and convenience. You have my slides. And with this, the contracted engineers were able to construct an intervention plan. And the intervention plan was merely just to increase the phase pressure as we were get close. But how much do we need to increase? Too little, you get an active collapse. When you're too much, you get a passive sort of, you're pushing the piles away. So this is a bracket that they come up with. And I'm sure they have done a couple of iterations to find the most optimum pressure to sort of apply when the eastbound tunnel gets closer to the sensitive structures. So with the 4 case histories, I want to summarize it. In case 1, we talk about the importance of visualization, and inception of the technical problem is important. Knowing the in situ ground and its genesis. Visualization and good 3D modeling allow us to visualize the progression and the possible mechanisms at play. So case 1 basically touches on aspect 1 and 4 of the geotechnical triangle. Case number 2, it's important to understand the modeling space, whether to use a 2D and 3D. Most of the time we go for 2D because it's cheaper to run and it's faster, but 2D is there are a lot of assumptions and simplifications needed. And 3D, most of the time, is a model we do. But of course, when you do a 2D, 3D, you can also back check. And case 2 demonstrates the importance of getting the correct response and mechanism using the correct modeling space. So that means how you idealize it, how you bring the 3D problem or 4D problem in situ into your computer screen. Case number 3 touches on aspect 2, 3, and 4, mainly. Selecting the appropriate material model to obtain the correct response. You need to validate and verify so that you can back check and back analyze the collapse. So the validation process and the verification process is very important. This was demonstrated by the collapse of the deep cement mix wall. And number 4, this was concerning the twin tunnel, stacked top bottom. And these basically requires the it touches sort of four aspects. You need to, first of all, know the ground profile, back check, build up that ground model. Then number 2, selecting the correct material response for the ground and also for the tunnel. And aspect number 3, the building the model in 3D, modeling the tunneling process. And number 4, of course, experience is needed to see whether the outcome of each of this analysis is the correct direction. And once we know is the correct direction, we sort of refine it to sort of bracket the response, and at the end of the day, to come up with a solution to intervene with imminent collapse. So that was part 1 and part 2. And finally, let me go to part 3. Part 3 is concerned with emerging technologies. And in the coming future, these technologies will be very important, and especially more so when we're dealing with forensic work. Now, the first one I'm going to show you is about the use of drone technology to build a model here. This is what we call the ground truth. It can be way before a construction is done to find out what we have and what are the location of the sensitive structures and the interaction between the structures and the ground condition. This, when it is interlaid with the underground soil profile, is very important. All right. So this is the first one. Of course, when you have a collapse of forensic investigation, a drone technology can also be used to capture the final state of the in situ conditions here. Now, number 2 is a bigger scale. This is in Paris. This is done with what they call it a city scale kind of digital twin. The model can be enriched as it moves forward, and this is the technology of the future. And what we're showing here is, for example, you're looking at tunnels beneath a city. If you want to make an asset count to sort of look at what are the assets that are located along the alignment. And these were all captured using a technology called Orbit, with a car driving around the city. And these are all captured with photogrammetry and also with LiDAR to build up a very rich kind of information. And this is still to figure out what we have. And these are very important because we can use it to sort of earmark what are the structures that need to be monitored and what are the sensitive ones, whether it's heritage, and so on and so forth. So these are all very important technology that I think in future will play a huge role, an important role in looking at the technical modeling and also looking at the forensic engineering here. And finally, this is something that has been happening. And in this seminar itself, there was a lecture that's concerning INSAR. And INSAR is one of the things that are very important because once you have the data, you're able to sort of backtrack what are the settlements. And what you're looking here, I have borrowed a slide from the Crossrail. You can see that on the top here, the red marks are basically the location of the Crossrail railway tunnel. And you can see that how the INSAR can actually give you the data of the settlements. Now, if you look at another piece of work which was done by a researcher from Italy, I will quote these reference later. And these are done by another called INSAR technique. The INSAR technique, if it's good enough, it's also good, sufficient enough for you to look at the volume loss. These are the so-called settlement curves that you can, or normally traditionally being captured using optical points right at the surface. But of course, using INSAR, if it's well done, you can also obtain the surface settlement. And you can see that if you have this sort of measurements on an area of consideration, you can see how the, even you can get a glimpse of the location of the lines beneath the ground. And finally, in our own arsenal of technology in the Bentley systems, this is a technology known as the using GIS, a like scale GIS, which is actually, you can look it on the web page. Now, this is consisting of a railway project or tunnel project in Gothenburg in Sweden. And what you're seeing here are the integration of all the technology, the soil data, giving you the ground profile, the infrastructure itself, and how it's interlinked with the ground. And also the, you can see here, based on drone surveys, the location of structures on top of it. So this is like a first phase of a digital twin type of a project. And of course, with this, you can see and also document the progress. And also, as you go along analysis and field monitoring, you can enrich the model. And these are all very important because it tracks the progress, it tracks the construction, it tracks the performance, and the event there's any conflict of interest, or also perhaps even a type of excessive movements where you need to sort of back analyze, or even sad to say, if there's forensic, means if it's collapse work, at least your forensic back analysis, you can refer to these sort of models that have been gathered initially. So let me conclude my presentation. Part 1, Part 2, Part 3. Part 1, I talk about geotechnical analysis and the crucial role it plays in forensic geotechnical engineering. More often, the success of forensic geotechnical analysis is connected to many aspects, which we have demonstrated using the geotechnical triangle. These are all interconnected. There's no one single tool. You must have the tools to sort of allow you to sort of look at the different things. Now, part 2, I have summarized it. And part 2 basically touches on all the different aspects that needs to be considered. And all these 4 aspects basically in this presentation is connected to back analysis using advanced geotechnical techniques or advanced computational geotechnical techniques here. Now, part 3, technology, of course, plays an important role in the coming future, especially with the Industrial Revolution number 4. And sometimes we call it construction revolution number 4, even geotechnical revolution number 4. The ability to sync and share data in a convenient way will expedite and reduce errors. Going from ground to cloud, meaning digitizing and building ground truths, geotechnical twin models, and allow us to better predict the performance of geotechnical structures. Digital twin, in a way, tracks the inception of the model, its design and analysis, construction, and performance during its lifetime. So basically, with this information, in the event of any forensic problems, you can always backtrack and check. So with this, I thank you for your time and attention, and also thank my co-workers. If I made any errors, it's all my own fault and accord. And then now I would like to open the floor for questionnaires. Thank you so much, Chairman.
Thank you, Dr. William Chiang Wailam, for your amazing presentation just now. Now we are open for Q&A session.
Thank you.
All right, we open for the question for the audience. Audience may post your questions through our YouTube channel or by Facebook.
So
okay,
I guess you're seeing some, yeah, go ahead.
We have one question. Okay, does the INSA technique has some limitation?
I'm not an expert to speak about INSA, but I've learned about what it can do. Any technology will have advantages and disadvantages. But personally, based on my own experience as a consulting engineer and also a teacher, is that this method of remote sensing, we call it remote sensing, allow us to look at some of the movements way even before we put in a settlement marker. Okay, to measure movements, you need to put a marker there, whatever instruments. These are all so-called physical type. But imagine you're able to tap on some of the satellite data stretching back 20 years. You can even ascertain what sort of movements way before you even got into the site. And there are many papers that is around that also showcase how the INSA was able to detect the collapse. Perhaps you have seen a collapse that was happening in Italy of a bridge. And not many years ago, there's a Hong Kong building was collapsed. So it's able to say that even they can even track how the rate of movements were moving fast. Of course, to come up with these sort of data sets, you need an expert in these geospatial analysis to be able to come up. And what I've learned so far is that you need to have the data sets to come up with these measurements. There are many types of the INSA method, the PINSA and the DSA itself. So my opinion is that you need to seek an expert in that area to give you a good detail. But having said this, I think geotechnical engineers should know what this technique can do so that they can comprehend how it can be applied here. In this seminar itself, I think there was a presentation on that, so perhaps you can refer to it here. Thank you.
Okay, thank you, Dr. William, for the Q&A session. Thank you for sharing your expertise in this session.
Thank you so much for having me. Terima kasih.
Thank you.
Yeah.
Dear ladies and gentlemen, we will have a short break. Please note that after the short break at 3:30 p.m., we will have our last presentation by Dr. Muhammad Niza bin Abdul Rahman from Public Works Department of Malaysia. Thank you. Ladies and gentlemen, we are going to continue our session with the last presenter by Dr. Muhammad Nizar bin Abdul Rahman from Public Works Department of Malaysia. Please welcome Dr. Muhammad Nizar bin Abdul Rahman to present topic entitled Adaptation of LIDAR and GIS in Monitoring Debris Flow Prone Location. Dr. Muhammad Nizar, the floor is yours.
Good evening. Thank you, Mr. Zakwan, for the introduction. So I'm Muhammad Nizar bin Abdul Rahman from Slope Safety Section, from Slope Engineering Branch, PWD. Okay, so today I'll be sharing our experience in the adaptation of LIDAR and GIS in monitoring debris flow in Malaysia, especially in Peninsular Malaysia. So the layout of my presentation is a bit of introduction on Slope Engineering Branch, Industrial Revolution, slope failures, and also a couple of case studies in Lodging Kelantan and also Yan Kedah. So this is the structure of Slope Engineering Branch, Public Works Department of Malaysia, where there are 5 divisions under the Slope Engineering Branch, namely BPKS, BKC, BPPBC, BFTR, and also BTTC, where all of these divisions are in charge of slope monitoring and slope maintenance works under Public Work Department. Okay. So this is just some information on federal route slopes. Okay, there is about 26,791 slopes registered under Slope Engineering Department branch. Okay, where there is about 2,600 slopes which are categorized as very critical and critical. Okay. So about Industrial Revolution. Okay. So the first Industrial Revolution began in 18th century, where steam power and water powered mechanization was introduced in the industry. Okay. Then it evolved to second evolution in 20th century, where mass production, assembly lanes, and with the help of electricity was introduced in the industry. Okay. Then in 1970s, the third revolution was introduced by the use of computers and also factory automation. Okay. And now, in today's scenario, we are in the fourth revolution, where a lot of cyber-based technologies are used in our industry. Okay. So according to CIDB, in the Construction Strategy Plan 4.0, these are 12 main technologies listed by CIDB, which will change the construction landscape in Malaysia. So I'm more keen on the 6th technology, which is 3D scanning and photogrammetry, which are used by us in the slope maintenance to identify slope failures and also in identifying the debris flow prone areas. Okay, so LIDAR is a laser-based technology which are connected to the fixed wings, which are aeroplanes, or also drones, to survey the land to get a better and more accurate and fast data on the land survey. Okay. So this is fast, connected on the drones. Okay. Then this is the data we will receive from the LIDAR. Then this data will be keyed in the GIS system to get more rasters. Okay, which we can identify a few slices, whether it can be flow accumulation or stream network slice, or slope angle, or hill shade, contour, catchment, and land cover. Okay. From the land cover slice, we can identify cover of the land, whether it is a developed area or a forest or bushes, grass or bare area. From the catchment slice, we can identify layer, catchment area, which will have a direct influence on the flow of water. And we also have contour slice, which shows the contour raster, where high slope are associated with lower stability. So we can identify these high slopes. And also there is a slope angle slice, where we can identify slopes between 35 to 50 degrees, which are assumed to be more prone to debris flow. Okay. Then final one is flow accumulation or stream network, which can show high flow accumulation and high saturation, which will cause high saturation and high soil erodibility. Okay, it's the same. So types of failure. Okay, there are a few types of failure when involves slope. Okay, which are, the first one is fall, and second one is topples, when the soil fails in the manner of topples. Then we have slides, okay, and spreads, and also complex. Okay, this is according to Wang, Li, and Melching, 2015. Okay, then according to Stinney, 1910, okay, he described debris flow as flood in a mountain torrent carrying suspended loads and transporting quantities of bad load. As the amount of sediment carried by the flow increases, at a certain limit, it has changed into a viscous mass consisting of water, soil, gravel, rocks, and wood mixed together, which flows like a lava into the valley. Okay. Okay. And another definition by North American Landslide Classification System by Wans, 1978, and later modified by Cruden and Wans, 1996. Debris is called, the flow is called as debris flow when there is more than 20% of gravel and coarse-sized material in the flow, while it is considered as earth flow if the coarse-sized materials are less than 20%. Okay, I'll show you a video of how the debris flow occur in Malaysia. Okay. So this is the simulation from TikTok by Ini Saiful. So when there is a heavy rain on the hill areas, okay, there might happen landslides, which will block the rain, stream flow. And thus creating accumulation of water behind the landslide. And at a point, this natural or temporary dam will break, and thus causing the debris flow with high velocity water flow. So the velocity of debris flow can achieve up to 60 to 90 kilometers per hour. There are about 5 triggering mechanisms highlighted for which can contribute to debris flow, which are first rainfall, second is melting of ice or snow, and third one is earthquake, and fourth is volcanic eruption, and the last one is the destruction of lake and dam. Okay. So far, according to our experience, most of the debris flow in Malaysia are caused by rainfall. So this is another debris flow in Ilgraben, Switzerland. You can see how the debris are washed in the flow. The flow is very strong that it can move very big size boulders, sometimes 2 to 3 meters in diameter, easily moved like it is nothing. So from the video you can see the destruction force of the debris flow. And after the flow, for sure it will change the topographic of the valley along the debris flow. It's another video at the same location. So debris flow can be contributed by the following reasons, which are first, debris flow due to gully bed erosion, where a gully which has not been repaired would create a concentrated path for debris flow to occur when large surface runoff is present, okay, where the runoff will erode the soil and cause slope slides or failures. The second is debris flow induced by landslide, where a landslide could trigger debris flow as the retained water upstream followed the landslide downhill. And the third one is debris flow induced by collapse of natural dam, where a natural dam created along the natural stream course by timbers or loose soils and rock will trigger debris flow when the dam breaks, as you saw in the first video just now. Okay. According to Asandi, the main characteristics of debris flow are it usually occurs in steep natural slopes area, and then second is it occurs in valleys in between hills, and third one is the movement is relatively shallow compared to the landslides. Then fourth is usually the debris flow terminates at the base of the slope, and the last one is usually this kind of failure occurs in the area where a large of catchment area is available. So this is the debris flow occurrence in Malaysia. Okay, so you can see since 1995 there are about 18 cases reported. Okay, and most of them have involved casualties. Okay, the worst one it was in December 1996 in Keningau, Sabah during the quake. So the most recent one is the number 17 and 18, which in January 2021, there's a debris flow in Lodging Go Musang Road in Kelantan at section 60. And in August 2021 at Yan Kedah, or known as the Gunung Jerai incident, okay, where 6 people were killed in the phenomena. Okay. So I'll explain a bit about our experience in Lodging Go Musang, which occurred in 3rd January 2021. Okay, this is the route FT185, which is a federal trunk that connects Perak with Kelantan and also Pahang. Okay. So during the incident, during the day of the incident, okay, the rainfall recorded was about 142 mm per day. Okay. So the debris flow occurred when the rainfall was assumed as around 100 to 120 mm per day. Okay. So the location was near Sungai Peringgi Bridge. Okay. So the consequences was damage to the far right bridge beam, but just cracks, and the beam is still intact. Then there's a bridge abutment eroded. The bridge abutment eroded, damage to pavement at section 60 to section 60.2, and also damage to pavement from section 60 to section 62, about 2 kilometers. And also road accessories like guardrail were damaged from section 60 to section 62. These are the pictures. Okay, so you can see the debris flow started from all the top and downwards towards the road. Okay, so you can see there's a bridge over here. Okay, so when the debris already congested the bridge opening, so it overflowed to the road, thus damaging the pavement and all the accessories. So you can see the flow went all the way about 2 kilometers, and along the way it damaged the pavement. So this is the picture taken by JKR Gua Musang right after the incident. So you can see all the boulders and fallen trees, tree trunks were washed during the debris flow. Okay. Even during the incident, the flow of water on the road is like a river. So cleaning works have to be done fast, especially under the bridge, so that in case any consecutive rainfall, the water can flow freely under the bridge, so and won't overflow to the road again. This is the part of the debris flow from the hillside. So you can see the damage done throughout the flow. Okay. So the clearing works was carried by JKR Gua Musang. Okay. So we used the LiDAR to get some data at this area, and after keyed in and analyzed in the GIS, so this is the hillshade slice raster that we get, which shows the catchment area at that location and the failure area. So the debris flow started at the catchment area and flowed all the way to the failure area. So the stream network shows there is natural streams that will only emerge during heavy rainfall. Okay, so all this stream will accumulate right at the location where the failure occurs. And this is the slope angle. Okay, from the location that initiated the debris flow, okay, the slope angle is between 25 to 60 degrees. So that is a very prone area for debris flow and also landslides. Okay, next one is at Gunung Jerayan. Okay, the incident occurred in 18th August 2021. So during the occurrence, the rainfall recorded was around about 281 millimeter per day, which is equivalent to 70 years of ARI, or return period for the rain. And the debris flow was detected when the rainfall reached 244 millimeter per day. So this is the video which was captured by amateurs and was uploaded to YouTube, which shows how bad the condition during that incident. a lot of natural waterfalls can be found along the hill area. This is at the location at Titi Hayun. This bridge was washed out after the incident. This is accumulation of rainwater in the form of stream. The volume of water was already very high, so it already overflowing the bridges. A lot of debris can be found after the water extract along the river and also under the bridges. Okay. So this flow already, same as in Gua Musang, it damaged the pavement and also caused landslides. Slope failures at this area. All these are locations for for tourism spots. So this resort was actually seated next to the river, a bend of river. But during this incident, the water passes straight across the resort. This is at the downstream area. No debris, but water, only water, which brings silt and also clay, mud siltation. Okay, so this is how it looked after the incident. Okay, you can see a lot of scars at Titi Hayun, where indicates a lot of landslides occurred during the rainfall. Okay, this area, according to our soil investigation, it shows that the thickness of the soil is just 3 to 6 meters, and followed by granite layers. Okay. So in Batu Hampa, you can see the aftermath of the debris flow. All these are thanks to JMG Kedah Perlis Pulau Pinang. Okay, this is Tupa water plant. Even the water plant, the walls are moved during the debris flow. This is at Sri Perigi, which you saw in the video just now. Okay, this is the damage done at the Sri Perigi. This is a geopark, right, for your information. So this one is at Titi Hayun. A lot of debris, a lot of boulders and rocks can be found at the location. In Batu Hampa, the damage is almost similar, okay, at all the location. And this is at the Alang Kenari, the resort I mentioned just now. A lot of tree trunks were washed in the incident. This is at Salak Denai. And this one is in Jalan Gunung Jerai at FT 252 on Gunung Jerai. Okay. Almost a side of the road was affected by the landslides. Okay, so this is the graphic provided to us by JMG. Okay, from the data they acquired from JUPAM, the LiDAR data. So this is the location. There's 1, 2, 3, 4, 5 locations. Okay, so the debris flow was detected in Zone 1 in Titihayon and Zone 2 in Batu Hampa. Okay, while in Zone 4 there's small scale debris flow, and at Gunung Jerai there was a few landslides. So this is the shade of the mountainous area at this area. Okay, so the water is collected following the arrows. Okay. This one is at Gunung Jerai Road. Most of the, almost all the landslides were occurred at the natural stream. And the slope angles at these locations are between 25 to 60 also. So for the conclusion, it can be concluded that we can use LiDAR survey data and GIS application to come up with contour map, slope angle, and stream network and flow accumulation and also watershed for the locations or the slopes involved. This can be done very quickly by using drones for a smaller area or by using fixed wings for a larger area. Okay, and these data are very reliable. Okay, and it is have a high potential to be used to for mapping the debris flow locations. Okay. So as a way forward, we are working with local universities to establish threshold value, okay, for the debris flow trigger mechanism, where, as I mentioned just now, one of the main reasons why this debris flow occur is rainfall. Okay, when the rainfall achieves certain limit, then the probability for landslide or even debris flow is very high. Okay. Then also we want to see the connection with geological features and also geotechnical features, which can cause the debris flow or even landslides. Okay, so I would like to take this opportunity to convey my acknowledgement to Slope Engineering Branch, Jabatan Mineral and Geoscience Malaysia, Kedah Perlis Pulau Pinang Branch, and also Jurutera Jajahan JKR Jajahan Gua Musang, Kelantan. So thank you. That's all from me.
Thank you, Dr. Muhammad Nizar bin Abdul Rahman, for your amazing presentation. Now we are open for Q&A session.
All right, we have one question from the audience. Okay, the question is, what is the range of accuracy for airborne LiDAR measurements of land topography and water bathymetry? Bathymetry.
Water bathymetry.
Bathymetry. B-A-T-H-Y.
Okay. Okay, thank you. Just a bit confused about the water bathymetry.
And water bathymetry.
Boleh tengok soalan?
Okay. All right.
So, thank you for the question. So, the person wants to know, Mr. Afi wants to know about the accuracy of using the LiDAR for the survey mapping. So, as far as concerned, it is very accurate, okay, in terms of the survey, and it is as close as possible with the actual condition of slope as we can find at the site. Thanks.
Okay, thank you, Doctor, for the Q&A session. Thank you for sharing your expertise in the session. Thank you, Doctor.
Thank you.
Ladies and gentlemen, with the end of presentation by Dr. Muhammad Niza bin Abdul Rahman just now, we have come to the end of the international seminar on forensic engineering. Before we conclude, I would like to leave you with a quote by Stewart Brand, an author and innovative thinker who once said, "We can see the past but not influence it, but we can influence the future but not see it."
Let us all be guided by all the things we have learned and heard throughout the seminar and be able to see and influence our future.
On behalf of the Secretariat, we would like to say a big thank you to all of the speakers and participants of the seminar. May the knowledge that we gain in these 2 days will help improve our delivery system by building better and safer infrastructures for the peoples.
Thank
you very much.
And Assalamualaikum warahmatullahi wabarakatuh.